गुड इवनिंग आदित्य। क्लियरेंस प्लीज। आदित्य विल गुड डे। ऋषभ केशारी, अमित पासवान, वेरी गुड इवनिंग बेटा। So boys and girls, welcome back. Khaleel Khan here, welcoming you to algorithm part 2. तो जैसे हमने पार्ट 1 में कहा था कि वी आर गोना डिस्कस द रिमेनिंग टॉपिक्स, जहाँ पर हम डिस्कस करेंगे ग्रीडी मेथड एंड डायनामिक प्रोग्रामिंग पर्टिकुलरली, एंड इफ पॉसिबल डेफिनेटली ग्राफ टेक्निक्स, ग्राफ एल्गोरिथम्स आल्सो with regard to traversals. So boys and girls, I hope you're all doing well और आपकी स्टडीज भी अच्छी चल रही होगी। तो आई थिंक विदाउट वेस्टिंग मच टाइम, लेट्स प्रोसीड टू स्टार्ट विद द डिज़ाइन मेथड्स, पर्टिकुलरली ग्रीडी मेथड, उसके बाद डायनामिक प्रोग्रामिंग। सो लास्ट क्लास में और लास्ट सेशन में हमने देखा था विथ रिगार्ड टू एनालिसिस इन डिटेल, और उसके बाद हमने कवर किया था डिज़ाइन स्ट्रैटेजी बाय नेम डिवाइड एंड कॉन्कर। Like divide and conquer, greedy method is also one of the simple topic, one of the simple design strategy जिसके बेसिस पर काफ़ी प्रॉब्लम्स है, काफ़ी एप्लीकेशंस है, काफ़ी आई मीन एरियाज है जहाँ पर greedy method you try to use it। तो हम देखेंगे what is the basic ideology of greedy method, और उसके बाद what are the typical applications जो prominently important है from GATE perspective। कहना यह है बच्चों के ग्रीडी मेथड और डायनामिक प्रोग्रामिंग के लिए कॉमन टर्मिनोलॉजी है जो हमेशा मैं पढ़ाता हूं, एंड आई वुड एडवाइस के स्टूडेंट्स फॉलो दैट टर्मिनोलॉजी वेल। अगर आप वो टर्मिनोलॉजी को अंडरस्टैंड करोगे, यू कीप दैट इन माइंड, आई एम वेरी श्योर कि आपको समझने में काफ़ी आसानी होगी। सो आई विल ब्रीफली टच अपॉन दोज रिलेवेंट टर्म्स ऑफ ग्रीडी मेथड एज वेल एज डायनामिक प्रोग्रामिंग, राइट? ठीक है, तो सबसे पहले आई विल टॉक अबाउट टर्मिनोलॉजी। वेरी ब्रीफली आई विल टेल, एंड आई एम वेरी श्योर अगर आपको पता ना हो तो भी आप समझ पाओगे। सो अगेन आई रीएम्फसाइज कि ये जो टर्मिनोलॉजी है, दिस इक्वली अप्लाइज टू नॉट ओनली ग्रीडी मेथड बट आल्सो डायनामिक प्रोग्रामिंग, एंड टू सर्टेन एक्सटेंट मेनी ऑफ द टर्म्स आल्सो अप्लाई टू बैकट्रैकिंग एंड ब्रांच एंड बाउंड। हालांकि बैकट्रैकिंग एंड ब्रांच एंड बाउंड आपके सिलेबस में एक्सप्लिसिटली नहीं है, लेकिन फिर भी ये टर्मिनोलॉजी के बाद टर्म्स इक्वली अप्लाई होते हैं for backtracking and branch and bound. Yes, very good evening again, Hridya, Upad, Uddhav, Yash, and Tulika. Very good evening again, Amit Paswan. तो चलिए बच्चों स्टार्ट करते हैं टर्म्स। फर्स्ट, नंबर 1, वी हैव प्रॉब्लम डेफिनेशन। जिस प्रॉब्लम को आप सॉल्व करना चाह रहे हो उसका डेफिनेशन की क्लैरिटी होना चाहिए, उसका डेफिनेशन क्लियर होना चाहिए। Boys and girls, I am to tell you that every problem will have something called constraints. अगर आप जेनरिक टर्म्स में पूछोगे तो constraints का मतलब है conditions, requirements. I am to tell you that constraints are of two types, boys and girls. दो टाइप के constraints हैं। हर एक प्रॉब्लम में implicit constraints होंगे and explicit constraints होंगे। Implicit and explicit constraints. Implicit constraints are the boundary of, I mean, are the local conditions of the problem. हर एक प्रॉब्लम के अपने own implicit constraints होंगे जो आपका solution satisfy करना होगा। ये टर्मिनोलॉजी को बेटर अंडरस्टैंड करने के लिए, बेटर अंडरस्टैंड करने के लिए आई फील इट नेसेसरी कि मैं एक सैम्पल प्रॉब्लम लूं। जनरली आई गिव दैट प्रॉब्लम एज एन एग्जांपल टू मेक यू अंडरस्टैंड द टर्मिनोलॉजी। प्रॉब्लम ये है कि बेसिकली इट्स ए गेम प्लेइंग प्रॉब्लम जिसका नाम है एन क्वींस। आई एम वेरी श्योर सभी बच्चों को पता है एन क्वींस प्रॉब्लम क्या है। इट्स ए गेम प्लेइंग प्रॉब्लम, बॉयज एंड गर्ल्स। वी आर गिवन एन क्वींस and n by n chessboard. Like for example, if I take 4 queens, मैं सिर्फ आपको constraints का मतलब समझाने की कोशिश कर रहा हूं। n is equal to 4, we are given 4 queens, q1 to q4, और हमें चाहिए ये queens को चेस बोर्ड पर, ये जो बोर्ड है 4x4 चेस बोर्ड, n by n चेस बोर्ड, we are required to place the 4 queens on this chess board। इस तरीके से प्लेस करना है कि they are non attacking, मतलब दे शुड नाइदर बी ऑन द सेम रो, सेम कॉलम, सेम डायगोनल। तो बच्चों ये जो तीन कंडीशंस है, रो, कॉलम, डायगोनल कंडीशन, दीज आर कॉल्ड इंप्लिसिट कंस्ट्रेंट्स ऑफ द प्रॉब्लम। इसी तरह हर एक प्रॉब्लम के अपने ओन इंप्लिसिट कंस्ट्रेंट्स होंगे। देयर विल नॉट बी एनी प्रॉब्लम विदाउट इंप्लिसिट कंस्ट्रेंट्स। एक्सप्लिसिट कंस्ट्रेंट जनरली डिफाइन द बाउंड्री, मतलब द साइज ऑफ इनपुट या आपका जो आउटपुट रिप्रेजेंटेशन होगा, राइट, that you put some constraints on it, that is called explicit. Like a solution of the problem is expressed in terms of a vector x1 to n. तो यहां पर आप कहोगे each xi take value in the range from 1 to n. Every xi indicating the position of queen I indicate the place where the queen is placed, the column in which the queen is placed. So you are limiting the value. You are limiting the value of x of I to take values in the range from 1 to n. That is called implicit constraints. Explicit constraints, boundary of the problem. Row, column, diagonal are implicit constraints. The value of n, the range that xi can take, limiting value that xi can take from 1 to n, that is called explicit constraints. So boys and girls, every problem will have implicit and explicit constraints. Now based on the constraints, explicit constraints, you have something called the solution space, a very important term, जिस बेसिस पर आपको हो सकता है 1 मार्क क्वेश्चन पूछा जाए। एवरी प्रॉब्लम में हैव इट्स सॉल्यूशन स्पेस। द ब्रूट फोर्स का जो कॉन्सेप्ट है इज बेस्ड ऑन सॉल्यूशन स्पेस। ऑल पॉसिबल वेज ऑफ ऑर्गेनाइजिंग द इनपुट्स वेदर satisfying the implicit constraints or not, all possible ways. जैसे कि फॉर एग्जांपल n queens प्रॉब्लम में all possible ways of placing the queens on the chessboard, whether attacking, non-attacking, but meeting explicit constraint, that is called solution space. तो solution space generally is expressed in the form of a mathematical function. जैसे कि अगर n queens की बात करो आप, the size of solution space of n queens is n factorial. 1 2 3 4 1 4 2 3 1 3 2 4 1 4 2 3, right? 2 1 4 3 2 4 1 3, all possible arrangements, factorial n. The size of solution space of every problem is expressed as a mathematical function. किसी problem का size infinite भी हो सकता है, solution space infinite भी हो सकता है, ठीक है? So this could be a 1 mark question for the problem. Boys and girls, please remember, कोई भी problem का solution space could be asked as a simple 1 mark question. ठीक है? Solution space. Now after solution space, we have to find something called feasible solutions. Feasible solutions. Feasible solutions are those solutions in the solution space that satisfy implicit constraints. वो solution space के जो implicit constraints को satisfy करेंगे वो है feasible solutions. Feasible का मतलब है correct, that satisfy implicit constraints. जैसे कि one of the feasible solution for this problem क्या होगा? One of the feasible solution is 2 4 1 3. 2 4 1 3 means you are placing the first queen. You are placing the first queen in second column, second queen in fourth column, third queen in first column, and the fourth queen in third column. ये है feasible solution. A problem may have more than one feasible solutions. Instance of the problem, zero solution हो सकते हैं, zero feasible. जैसे कि 3 queens problem, zero feasible solution. 2 queens problem, zero feasible solutions. A problem may have zero feasible solution depending on the instance, or a problem may have more than one feasible solutions. I can have multiple feasible solutions. समझ रहे हो? ठीक है. Then the next term that we need to define is something called objective function. Objective function. Few problems will have something called objectivity. Objectivity is nothing but the thing which you would like to minimize or maximize. Minimize or maximize some criterion. Minimize or maximize some criterion function. Criteria. अगर कोई प्रॉब्लम में डिस्टेंस है तो आप शायद हो सकता है शॉर्टेस्ट पाथ में डिस्टेंस को मिनिमाइज करना चाहोगे. कोई प्रॉब्लम में अगर प्रॉफिट है तो यू वुड लाइक टू मैक्सिमाइज द प्रॉफिट. किसी प्रॉब्लम में पेनाल्टी है, यू वुड लाइक टू मिनिमाइज द पेनाल्टी. तो हमेशा याद रखिएगा ऑब्जेक्टिविटी ऑलवेज रेफर्स टू मिनिमाइजेशन और मैक्सिमाइजेशन ऑफ सम गिवन क्राइटेरियन ऑफ द प्रॉब्लम. प्लीज रिमेंबर बॉयज एंड गर्ल्स, ऑब्जेक्टिविटी इज नेवर टू मिनिमाइज द टाइम एंड स्पेस कॉम्प्लेक्सिटी, क्योंकि वो तो डिफॉल्ट क्राइटेरिया है, डिफॉल्ट क्राइटेरिया. ऑब्जेक्टिविटी इज ऑलवेज ए गिवन क्राइटेरिया इन द प्रॉब्लम. एक गिवन क्राइटेरिया होगा विच यू वुड लाइक टू मिनिमाइज, जैसे कि डिस्टेंस है, टाइम है. टाइम का मतलब नॉट टाइम कॉम्प्लेक्सिटी, टाइम ऑफ रीचिंग द प्लेस. पेनाल्टी है, प्रॉफिट है, एरर रेट है, रिलायबिलिटी है, समझ रहे हो, कॉस्ट है, आप मिनिमाइज करना चाहोगे या मैक्सिमाइज करना चाहोगे. So some problem will have, not every problem. Like अगर आप n-Queens problem की बात करोगे, there is no objectivity in n-Queens problem. समझ रहे हो? Searching problem, there is no objectivity. Knapsack problem, objectivity है. Minimum cost spanning tree, minimum cost, objectivity है. ठीक है? ये है criterion function. तो last term that we need to define is called optimal solution. Optimal solution. Optimal solution refers to the value. Always remember, optimal solution refers to the value. Is that value of the feasible solution which satisfies your objectivity? मतलब वो feasible solution which will maximize the profit, minimize the error rate or whatever the given criteria, that is called optimal solution. Optimal solution always refers to the value. Always refers to the value. समझ रहे हो? So always refers to, and I can't have multiple maximum values or multiple minimum values. So boys and girls, please remember, optimal solution is always unique. Optimal solution is always unique. I can't have two optimal solutions because I can't have two maximum values. I can't have two minimum values. So boys and girls, the problem which has objective function, we find optimal solution, and such problems in the literature, आप क्या कहोगे? Such problems are called optimization problems. जो प्रॉब्लम्स जिसका ऑप्टिमल सॉल्यूशन रहेगा, जिसका ऑब्जेक्टिविटी रहेगा, सच प्रॉब्लम्स आर कॉल्ड ऑप्टिमाइजेशन. और जो प्रॉब्लम्स जिसका ऑब्जेक्टिविटी नहीं है, लाइक n-Queens, देयर इज नो ऑब्जेक्टिविटी, तो उन प्रॉब्लम्स में सिर्फ आप फीजिबल सॉल्यूशन डिटरमिन करोगे. सच प्रॉब्लम्स आर कॉल्ड डिसीजन प्रॉब्लम्स. ये कैटेगरी है प्रॉब्लम्स की, डिसीजन प्रॉब्लम, ऑप्टिमाइजेशन प्रॉब्लम. डिसीजन प्रॉब्लम्स आर दोज हुज आउटकम इज यस और नो, ट्रू और फॉल्स. ऑप्टिमाइजेशन प्रॉब्लम्स आर दोज फॉर व्हिच यू वांट टू मैक्सिमाइज और मिनिमाइज सम क्राइटेरिया. You find an optimal value, minimum value or maximum value. So problems are categorized into two types: optimization problems and decision problems. Nishu Kumar, good evening. ठीक है? ये है philosophy of the terminology. तो बच्चों, आपको मुझसे मैंने आपको ये कहना है यहाँ पर based on this terminology. तो मैंने कहा था this terminology is common for greedy method and dynamic programming. तो यहां पर मैं आपको एक फंडामेंटल बात बता रहा हूं जो शायद आपको पता ना हो, तो सुनिएगा. ये जो सॉल्यूशन स्पेस है, जनरली दिस सॉल्यूशन स्पेस इज बेस्ड ऑन ब्रूट फोर्स. तो ग्रीडी मेथड विल अप्लाई सम स्ट्रैटेजी ऑफ लुकिंग फॉर द सॉल्यूशंस इन द सॉल्यूशन स्पेस. डायनामिक प्रोग्रामिंग विल अप्लाई सम स्ट्रैटेजी. बैकट्रैकिंग विल अप्लाई वन स्ट्रैटेजी एंड ब्रांच एंड बाउंड विल अप्लाई वन स्ट्रैटेजी. So based on the different strategies, I have different types of strategies for searching the solutions in the solution space, and that is the reason I said this terminology is common for greedy, dynamic, backtracking, and branch and bound. Again I repeat. So in the solution space, you apply a concrete strategy to search or look for the solutions. Greedy will apply its strategy, dynamic will apply its strategy, and backtracking and branch and bound. That's why the terminology is very, very super important, very important. ठीक है? तो चलिए अब आगे बढ़ के देखते हैं कि व्हाट इज द बेसिक आइडियोलॉजी ऑफ ग्रीडी मेथड. ग्रीडी मेथड इज यूज्ड फॉर सॉल्विंग प्रॉब्लम्स whose solutions are seen as a result of making a set of decision. मतलब जो भी प्रॉब्लम में यू नीड टू मेक ए सेट ऑफ डिसीजन, मुझे एक n डिसीजंस में बनाना है, फर्स्ट डिसीजन, सेकंड से ए सीक्वेंस ऑफ डिसीजंस, वी कैन थिंक ऑफ सॉल्विंग इट बाय ग्रीडी. हाउ आर दोज डिसीजंस मेड इन ग्रीडी स्ट्रैटेजी? दोज डिसीजंस आर मेड इन ग्रीडी मेथड by applying, देखिएगा टर्मिनोलॉजी यहां पर मैंने अभी जो डिस्क्राइब किया सारे वही है. प्रॉब्लम स्टेटमेंट, कंस्ट्रेंट्स, इम्प्लिसिट, एक्सप्लिसिट, सॉल्यूशन स्पेस, feasible, objective and optimal solutions. So greedy method is an algorithm design strategy used for solving problems where solutions are seen as the result of making a sequence of decisions. जिस प्रॉब्लम में भी you need to make a sequence of decisions, we can think of using solving it by greedy method. Okay? And the characteristic of greedy strategy is that these decisions are made in a stepwise manner. ये important point है. Stepwise manner. Step by step. Step by step it make the decision. Step by step, stepwise. Where at every step, ठीक है, okay. ठीक है. So these decisions are made in a stepwise manner. How are these decisions made in a stepwise manner? We'll see. Where at every step, out of all available options, at every step out of all available options, greedily select that option which satisfies the criteria. Greedily selects that option which satisfies criteria. Criteria से मतलब feasibility criteria है या फिर objective function है or whatever. So two important things है यहाँ पर. One है basically making the decision in a step-by-step manner, and at every step out of available options, greedily select that option which satisfies the objectivity. ठीक है? Satisfies the objectivity if objective function is defined. Satisfies the feasibility criteria if feasibility criteria is there. Either of them या both of them. या अगर सिर्फ feasibility criteria, you have to satisfy only feasibility criteria if there is no objectivity. अगर objectivity है तो by default it means if you are satisfying objectivity, इसका मतलब ये है by default you are satisfying feasibility criteria. ठीक है? That is the point. So working step by step. अगर आप diagrammatically समझने की कोशिश करो, like I have to make some end decision. These are state 1, state 2, state 3 and so on. I have to make state and end decisions. Nishu Kumar, that's correct. So what happens? I see what options are available here. Among all the options available, I apply greedy criteria. Greedily select that option which satisfies your objectivity or satisfies your criteria and come to the next state. When I come to the next state, I see again what options are available. Again the same thing. Out of available options, greedily select that option which satisfies. I come to the next state, and this process continue until I finally come to the last state. ये है basic ideology of solving problem based on greedy approach. अगर आपने operating system पढ़ा हो तो जैसे वहां पर भी आप देखो shortest job first greedy strategy, shortest seek time first, this scheduling algorithm, shortest seek time first is a pure greedy problem. So my dear students, boys and girls, okay, point is there are many real life situations, many real life applications जहां पर आप greedy strategy apply करते हो by default. You unknowingly or knowingly you apply. So it's a very important strategy for solving many optimization problems and many feasible solutions. Most of the optimization problems are solved by greedy method. समझ रहे हो? Are solved by greedy method. तो इसका जो criteria, इसका जो control abstraction है, mechanism है to describe how the problems are solved can be expressed by means of this control abstraction. This is called, ये procedure का नाम है control abstraction. Control abstraction का मतलब ये है कि procedure whose flow of control is clear, but the details of the steps are abstracted. Control abstraction. A procedure whose flow of control is clear, but the details of the steps are abstracted. Like for example, देखिएगा, we are solving some problem whose input is perhaps in an array of size and elements. Input है in an array of size and elements. So here the solution which I want to find, maybe a feasible or optimal solution. The solution is initialized to phi null. Then I have a loop for I is equal to 1 to n. X is equal to select of I. So select is an abstract procedure. So based on the options available, I am selecting one input from the array or from the list A, whatever you call. A is the input. I am making a selection of the input by applying some criteria. Then we have to check whether is it feasible, is it possible or not to include that input X into my solution. क्या ये जो input हमने select किया ये हमारे solution में हम include कर सकते हैं या नहीं कर सकते हैं, that is tested by a procedure called feasible. अगर feasible हो, if it is true, then I add it. Union का मतलब add करना, we add it. अगर ना हो तो we go for the next step. It's not possible, we go for next, and like that I repeat the loop for n times. So यहाँ पर read कीजिएगा, selects an input from A and removes it. The selected input value is assigned to X. Feasible is a Boolean function that tests whether is it feasible to include that solution or not, or include that input or not into the already constructed solution. If it is feasible, it will return true. Agar feasible na ho, to it won't return true. So boys and girls, this is the procedure for solving problems based on greedy method. So can you tell me, I have one simple question to ask. Any problem which is solvable by this greedy abstract procedure, जो भी problem आप solve कर रहे हो using greedy abstract procedure, this abstract procedure, whichever greedy problem you are solving by this control abstraction or by this abstract procedure, its time complexity will never be less than dash. एक important concept है, important point है to be note down. Any problem solvable by greedy method with this abstract procedure, उसका जो time complexity होगा, it will never be less than order of dash. बोलिए, will never be less than order of dash. No greedy problem will be solved with time less than dash with this control abstract procedure. Order of n. Order of n. Is it not? Order of n. When will it be order of n? कब होगा order of n? वो तब होगा, remember, वो तब होगा when feasible, union and select. These abstract procedures select, feasible and union are individually orders of 1. और ये जो abstract procedures say they are individually order of 1, then it will be order of n. Then it will be order of n. लेकिन परंतु अगर हम कहें कि for some problem, if feasible is done in order of log n time, boys and girls, अगर मैं कहूँ कोई particular problem में feasible procedure takes order of log n time, तो overall time क्या बनेगा? Overall time of the algorithm क्या बनेगा? Overall time of the problem क्या बनेगा? Order of n log n. Yes, Rishabh Keshari. Agar feasible can be done in order of log n time per iteration, overall time of the algorithm will become order of n log n. Agar feasible is done in order of n time, overall time banega order of n square. इस तरीके से आपने time decide करना है. So time complexity of greedy based problems generally is polynomial, but maybe there may be some exceptions, but most of the time it is polynomial. ठीक है? So this is the general approach of solving problem based on greedy method. इसके अब कई applications है जो most prominent application जिसके basis पर GATE में पिछले बार questions आ चुके हैं. One of the very important problem and one of the problem based on which there were questions asked in earlier papers is a simple problem, optimization problem जिसका नाम है knapsack problem. सभी को पता है, फिर भी मैं यहाँ पर definition लिखूंगा ताकि आपको समझने में आसानी हो. Knapsack problem. What is knapsack problem? Please understand, boys and girls, this is a good revision practice for you. So please, I will try to tell all the steps in short. We are given a knapsack. Knapsack का मतलब है एक bag. We are given a knapsack of capacity m. We are also given n objects. Each object is associated with its weight, let's say Wi, and every object will also have its profit, let's say Pi. On every object we have to make a decision. हमें decision लेना पड़ेगा हर object पर. Let's indicate the decision by xi. So this is what we have to find. We are given a knapsack which is उसकी capacity है m kgs आप मानिए, volume या capacity, mass जो भी हो. And every object has its weight Wi and its profit Pi, with an implication that अगर कोई object of weight Wi आप knapsack में डालोगे, knapsack will get filled up by the weight Wi and therefore you will get profit Pi. अब चूंकि यहाँ पर एक पैरामीटर profit है, naturally objectivity हमारी क्या होगी? To maximize the profit. तो problem definition ये है कि maximize the profit subject to what criteria? Subject to what feasibility criteria? Subject to what implicit constraint? Implicit constraint ये है कि the total weight that you put into the knapsack should not exceed the capacity. जो आप weight डालोगे knapsack में, it should not exceed the knapsack capacity. Are you getting my point? That is the base. So feasibility criteria is the weight being put into the knapsack should not exceed its capacity, or objectivity had to maximize the profit. Right? So by making decision on xi, I can say that the weight that goes into the knapsack is Wi xi. And the corresponding profit that I get is Pi xi. अगर मैं half object डालूं तो half of the weight जाएगा knapsack में और मुझे मिलेगा half profit. अगर 1/3 डाला तो 1/3 weight जाएगा and I will get 1/3 profit. समझ रहे हो बात? So this is the weight that is going into the knapsack with respect to decision on xi and this is the profit that I get with respect to the decision on xi. So this is the point. Boys and girls, one of the important explicit constraint जो satisfy होना है यहाँ पर ये problem में वो ये है sigma wi. Boys and girls, one of the important explicit constraint which should be satisfied in this problem is 1 mark question. Sigma wi must be dash than m. Boys and girls, if you remember, those of you who attended my class, I used to tell this. What must be the relationship for the problem to be non-trivial? For the problem to be solvable, non-trivial, what must be the relation between sigma wi and m? Yash Bedi, Rishabh Keshari, Aditya Velkude, please tell. Tulika, Nishu Kumar, tell me. What must be the relation between sigma wi and m? Must be greater than. Amit Paswan, not less than. Less than matlab problem become trivial, must be greater than m. Remember this as an important point. For the problem to be non-trivial, ka matlab to be solvable. To be solvable. Otherwise, if sigma wi is less than or equal to m, then basically the problem become trivial, unimportant, need not be worked out, because सोचेगा sigma wi is less than or equal to m का मतलब है you can put everything into the knapsack. I don't need to make any decision. All xi's will be 1. All xi's will be 1 if sigma wi is less than or equal to m, because I will get maximum profit. Sum of all. So sigma wi is greater than m, then only I say I have to maximize the total profit. क्या होगा total profit? Sigma pi xi. Sigma pi xi, I equal to 1 to n. Subject to what condition? STC, subject to what condition? Feasibility criteria. Subject to the condition that the total weight being put into the knapsack, जो weight आप knapsack में डालोगे, sigma wi xi, I equal to 1 to n, must be less than or equal to m. This is important. This is feasibility constraint. Boys and girls, people generally confuse between this and this. This is the total weight of all the objects put together. This is the weight going into knapsack. Boys and girls, these two are different. Don't confuse. Sigma wi का मतलब है total weight of all the objects. Sigma wi xi का मतलब है the weight going into the knapsack. Both are different. Sigma wi xi should be less than or equal to n. यहाँ पर आप लिखोगे where xi अगर आप fraction ले रहे हो, xi lie between 0 and 1, then this knapsack is called fractional knapsack. Real knapsack, fractional knapsack, greedy knapsack. Otherwise, if the value of xi is equal to either 0 or 1, then this is called binary knapsack. There are two versions of knapsack problem. वो knapsack जहां पर आप weight का fraction ले सकते हो, कोई object का fraction ले सकते हो, that is fractional knapsack. You can break the object and take the fraction. लेकिन और एक वर्जन है 0-1. 0-1 का मतलब यह है बाइनरी, मतलब you cannot take the fraction. Either you have to place the object fully or don't place it. 0-1. Boys and girls, 0-1 knapsack cannot be solved using greedy method. 0-1 knapsack has to be solved only with greedy dynamic programming and other strategies like backtracking and branch and bound. Yeah, philosophy. So in greedy method, we are going to work fractional knapsack. Or simple important point. So boys and girls, this is optimization criteria, मतलब objective function है, ये feasibility criteria है, explicit constraint है. Can you tell me what is the size of solution space? What is the size of solution space of greedy knapsack? What is the size of solution space of greedy knapsack? Let me see who will answer. Yash Bedi, Tulika, Rishabh Keshari, please tell. 1 mark question. What is the size of solution space of 0-1 of binary knapsack? Sorry, fractional knapsack, greedy knapsack. Greedy knapsack का solution space का size क्या है? I'm having n objects and a knapsack of capacity m. So how many values of xi can I have between 0 and 1? Fractional values, infinite. So all x1 to xn can take infinite values. So boys and girls, please remember infinite. So आप देखिएगा, अगर आप brute force approach apply करोगे for greedy method, for fractional knapsack, the size of solution space will become infinite complexity होगी. उसी तरह, can you please tell me what will be the size of solution space for binary knapsack? Binary knapsack का size of solution space बताइए, simple है. Now each xi is not taking infinite values. For binary knapsack, each xi is not taking infinite values. Every xi take either 0 or 1, 0, 1. x1 can take 0, 1. x2 can take 0, 1. x3 can take 0, 1. कितने values है? xn. n boolean variables. How many combination of values? 2 power n. So boys and girls, the point to be remembered, this could be 1 mark question. This could be 1 mark question. Okay, Purva Kulkarni, I will tell the person to upload. Don't worry. Suniega, the size of solution space of fractional knapsack, greedy knapsack is infinite. The size of solution space of 0-1 knapsack is 2 power n. Remember, 1 mark question hai. Om Savarkar, good evening, beta. So this is about the knapsack problem. So boys and girls, let's explore, try to find out what is the optimal greedy strategy for solving this problem, because there were questions based on this in earlier papers. So you should have the knowledge with regard to solving the greedy knapsack. So I'll take a simple data set and we'll try to apply the greedy strategy. Please see. Say for example, we are given 3 objects and a knapsack of capacity 20. Let's say the profits P1, P2, P3 are 25, 24, 15. The weights of the objects W1, W2, W3, 18, 15, 10. This is my data set. This is how the data will be given. So boys and girls, without going into much details, मैं आपको कहना चाहूँगा कि a problem can have multiple greedy strategies. You can be greedy about multiple parameters. I can be greedy about profit. I can be greedy about weight, or I can be greedy about something else. So a point is, I wanted to say कि एक problem के लिए I can have multiple greedy approaches. So can anybody tell me, for this problem I can have 3 approaches of greedy. Greedy about profit. That means you will try to place that object which is having highest profit. Greedy about weight, मतलब आप चाहोगे कि you put that object जिसका weight सबसे कम है, क्योंकि your objectivity is to accommodate more and more number of objects. Greedy about weight. But we have proved, I mean in my classes, if you know, neither greedy about profit nor greedy about weight will give you optimal strategy. सिर्फ अगर आप greedy about profit हो या greedy about weight हो, you are not going to get greedy optimal profit, final maximum profit. The optimal greedy strategy will be when I'm greedy about profit per uniform weight. Greedy about profit per uniform weight. Per uniform weight का मतलब when weight is uniform. सुनिएगा, यहां पर we cannot say 25 is highest profit weight. Why? Weights are different. अगर वेट सारे सेम होते 18, then this is highest profit. तो मुझे वेट्स को यूनिफॉर्म बनाना होगा. How can I make weights uniform? By taking 1 unit of weight. By putting WI units of weight, I get profit PI. If I take 1 kg of weight, 1 unit of weight, how much profit I get? This is called profit by weight ratio. So take 1 unit of weight of each object and see which object gives you maximum profit. So boys and girls, for this data set, if I find PI by WI ratio, P1 by W1 is equal to 25 by 18, P2 by W2, 24 by 15, P3 by W3, 15 by 10. तो ये वैल्यू है 1.5, ये वैल्यू है 1.6, ये वैल्यू है 1.3. So naturally, which object is giving you highest profit? The highest profit per weight is object 2, 1.6. So that means I want to find the values of x1, x2, x3. So from here I can say that the second object is going fully, so x2 is equal to 1. Weight of second object is 15. इसके बाद देखिएगा which object is having next highest profit by weight? Third object. तो third object का weight है 10, लेकिन हमें चाहिए 5 kgs. Why? Total capacity of knapsack is 20, जिसमें हमने 15 kgs fill up किया. Balance 5, so I have to take 5 units out of 10, half. And after that, there is no room for the first object, so x1 is equal to 0. So boys and girls, these are the decisions that you have made by applying greedy about profit by weight ratio. So based on this, the total weight that goes into the knapsack हमेशा full capacity होगा 20. Profit देखेंगे कितना बनेगा, sigma pi xi. First object का profit 0 है, सेकेंड ऑब्जेक्ट का प्रॉफिट 24 है, थर्ड ऑब्जेक्ट का प्रॉफिट हाफ है, हाफ ऑफ 15, तो ये बनेगा 31.5. नो अदर स्ट्रैटेजी विल गिव यू प्रॉफिट मोर देन दिस. This is the optimal, ideal, actual greedy strategy for solving fractional knapsack problem. Om Savarkar, both the approaches are there in exam. Om Savarkar, both the approaches, greedy and dynamic programming, दोनों हैं, दोनों important है. You cannot say this is important or that is important. तो ये है बच्चों, याद रखिएगा. प्रॉब्लम सॉल्विंग हम प्रैक्टिस क्वेश्चंस में देखेंगे इसके ऊपर के प्रॉब्लम्स और बेस्ड ऑन दिस. नाउ द टाइम कॉम्प्लेक्सिटी की अगर बात होगी, आई जस्ट वांटेड टू मेक ए मेंशन दैट टाइम विल डिपेंड ऑन बेसिकली पैरामीटर वेदर द ऑब्जेक्ट्स आर ऑलरेडी सॉर्टेड और नॉट. अगर ऑलरेडी सॉर्टेड होंगे तो टाइम कॉम्प्लेक्सिटी बनेगी ऑर्डर ऑफ एन. अगर सॉर्टिंग टाइम आप इंक्लूड करोगे इन द एल्गोरिथम तो फिर आपकी टाइम कॉम्प्लेक्सिटी बनेगी एन लॉग एन, बिकॉज मिनिमम टाइम फॉर सॉर्टिंग इज एन लॉग एन. आई कैनॉट हैव सॉर्टिंग लेस देन एन लॉग एन. So therefore comparison based sort में order of n log n is the time for sorting plus order of n for including the objects, so order of n log n. ये remember कीजिएगा. Accordingly you answer the question in the exam. Meanwhile I will go to the next problem, job sequencing with deadlines, JSD. It's a problem related to CPU scheduling. CPU scheduling के related problem है. So I will just summarize the discussion of the problem so that we can understand it. So we are given a single CPU. We are given a single CPU and n jobs, n processes. The characteristic of each process ये है कि their arrival time is same, burst time is 1 unit, and every job is associated with deadline and a profit. So let me write. Arrival time of all job is 0. The burst time of every job is only 1 unit. Okay? Every job has a deadline. Every job has its own deadline starting from 0. So therefore deadline is, let's say, di, an integer value, and we have a profit. Implication ये है कि deadline scheduling है, deadline scheduling in operating system. कि if you complete a job within its deadline you get profit pi. If you don't complete you don't get profit. और जैसे ही profit parameter है, हमारा objectivity क्या होगा? हमारा objectivity होगा to maximize the profit. तो problem का definition क्या है? Let me write the problem definition for you. Let me write the problem definition. The problem definition is very simple. We are supposed to select a subset of given कितने हैं n jobs. हमें एक select करना होगा subset. Yeah, it can come under Gantt chart. I will show some problem, don't worry. Nishu Kumar, thank you. STQC. Yes. चलिए, बहुत बहुत मुबारक हो निशु कुमार, बहुत बहुत मुबारक, बधाई. Very happy to learn that you got selected. Congratulations. So select a subset of given n jobs such that the jobs in the subset are completed within their deadlines in such a way to maximize the profit. We are having n jobs. वो n jobs में से एक select करना है हमें subset such that the jobs in the selected subset must be completed within the deadline. Completing the job within their deadlines is scheduling in feasibility criteria, implicit constraint. ठीक है? Okay, Vishnu, no problem. So jobs in the subset must all be completable within their deadline in such a way that you maximize the profit. ऐसा subset select करो जो आपको maximize करेगा profit. And condition is all the jobs in the subset must be completed within the deadline. Maximum subset क्या हो सकता है? All the n jobs. But generally because of conflicting deadlines, you may not be able to complete all the jobs. Jobs के deadline conflicting होने की वजह से you may not be able to complete all the jobs. तो how do you solve it? तो सबसे पहले आपको फिर वही पूछ रहा हूं, देखेंगे कौन बताएगा. Boys and girls, please tell me what is the size of solution space of this problem. बोलिएगा. What is the size of solution space of this problem? ये problem का solution space का size क्या है? Come on. Boys and girls. What is the size of solution space of this problem? 2 power n. Why? Because for n elements, how many subsets can I have? 2 power n subsets. तो कहने का मतलब ये है कि अगर ये प्रॉब्लम को आप सॉल्व करने की कोशिश करो यूजिंग ब्रूट फोर्स, इफ यू ट्राई टू वर्क आउट दिस प्रॉब्लम यूजिंग ब्रूट फोर्स, द कॉम्प्लेक्सिटी ऑफ द एल्गोरिथम विल बी ऑर्डर ऑफ 2 पावर n. ये बात याद रखने का है, 1 मार्क क्वेश्चन पूछा जा सकता है इस तरीके से, ऑर्डर ऑफ 2 पावर n. तो माय क्वेश्चन इज without 2 power n complexity, how can we solve in polynomial time? Because an efficient algorithm is one whose time complexity is bounded by polynomial. तो क्या हम ये प्रॉब्लम को पॉलिनोमियल टाइम में सॉल्व कर सकते हैं बाय अप्लाइंग ग्रीडी स्ट्रैटेजी? यस वी कैन डू इट. कैसे करेंगे देखेंगे, बाय टेकिंग सूटेबल एग्जांपल. सो आई विल टेक अ डेटा सेट बॉयज एंड गर्ल्स. फर्स्ट डेटा सेट, लेट अस से देयर आर 4 जॉब्स. लेट्स से देयर आर 4 जॉब्स J1 to J4. J1 to J4. Let's say their deadlines D1 to D4 are given something like this, 2-1-2-1, and their profits P1 to P4 is given as something like 105, 38, 18, 46, something like this. तो प्रॉब्लम को सॉल्व करना होगा by using Gantt chart. By using Gantt chart. सुनिएगा, मैं इसमें शॉर्टकट भी आपको बता रहा हूं. I am going to indicate the shortcut. Please follow carefully. So this is the CPU. Scheduling starts at 0. सबसे पहले you break up this into the slots of 1 unit each. 1 unit each. क्यों? क्योंकि every job take 1 unit of time. And second point, the maximum deadline is 2. Maximum deadline is 2. So therefore it means I cannot have more than 2 jobs. Naturally, जो maximum deadline होगी उतने मेरे jobs होंगे. So that's why I consider 2 slots. तो अब हमें करना क्या है? You start with the job. See, job with highest profit, be whatever its deadline, उसकी deadline जो भी हो, highest profit job की, you cannot sacrifice it at any cost. ये एक 1 mark question भी पूछा जा सकता है, reasoning question MSQ में. Job with highest profit, is it always includable or not? 100% included, sir. That is a greedy strategy. So the greedy strategy is, somebody said, Yash Bedi has written, arrange the jobs in decreasing order of profits. Arrange the jobs in decreasing order of profits. तो डिक्रीजिंग ऑर्डर ऑफ प्रॉफिट देखिएगा 105 है, इसका डेडलाइन क्या है? 2. सो यू शेड्यूल J1 in its maximum possible slot. J1 cannot be scheduled beyond this. J1 cannot be scheduled beyond this. तो आप मैक्सिमम स्लॉट में फिलअप कीजिएगा. नेक्स्ट हाईएस्ट प्रॉफिट जॉब इज 46. उसकी डेडलाइन क्या है? डेडलाइन 1 है. इज इट अकोमोडेटेबल? हाँ, J4 I can place it here. Deadline is 1. Have I filled up all the jobs? हाँ सर, that is my solution. I can stop here. अगर मैं चाहूं तो यहां पर स्टॉप कर सकता हूं. अगर नहीं, आप आगे जाना चाह रहे हो, नेक्स्ट हाईएस्ट प्रॉफिट जॉब 38, इट्स डेडलाइन इज 1, ऑलरेडी फिल्ड अप विद हायर प्रॉफिट जॉब, आपने डिस्कार्ड करना होगा. नेक्स्ट हाईएस्ट प्रॉफिट जॉब 18, डेडलाइन 2 है, डिस्कार्ड करना पड़ेगा क्योंकि यहां पर ऑलरेडी हायर प्रॉफिट जॉब्स है. यू कैनॉट अकोमोडेट 18. सो देयरफॉर माय ऑप्टिमल सॉल्यूशन इज सबसेट J1 J4 with a profit of 105 plus 46, 151. ये है सॉल्यूशन. चलिए मैं एक प्रॉब्लम न्यूमेरिकल दूंगा आपको वर्कआउट करने के लिए, देखेंगे कितने बच्चे वर्कआउट करते हैं. लेट्स से आई एम गिविंग यू 7 जॉब्स. द डेडलाइंस आर एज फॉलोज. D1 to D7 as say 4, 4, 5, 4, 3, 4, 5 and 5, 4. So 2, 4, 5, 6, 7. And their profits are something like this, P1 to P7. Let's say 88, 52, 34, 90. ठीक है? 10 and 60, 74. 1, 2, 3, 4, 5, 6, 7. Boys and girls, please work out this and let me know the answer. देखेंगे कितने बच्चे करेक्ट करते हैं. What is the maximum profit obtainable for the following jobs using JSD? What is the maximum profit obtainable for the following jobs using JSD? Come on, boys and girls, let me see who will respond. What is the answer for this? Five jobs. What is the profit? Rishabh Keshari. What is the profit? मैं ज्ञान चार्ट बना रहा हूं, मेरे आप भी देखिएगा मेरे साथ. Maximum deadline is 5. I can't have more than 5 jobs. I can't have more than 5 jobs. So यहां पर 1 2 3 4 5. ठीक है? This is CPU. So deadline slots 1 2 3 4 5. I can't have more than 5 jobs. Some people are saying 310, some people are saying 312. निशु कुमार 312 कह रहे हो आप, other people are saying 310. ठीक है, देखेंगे. हाईएस्ट प्रॉफिट जॉब है 90. 1 2 3 4 डेडलाइन है 4. So I will try to plug it in its maximum slot J1. Sorry, 1 2 3 4 J4. नेक्स्ट हाईएस्ट प्रॉफिट जॉब कौन सा है? नेक्स्ट हाईएस्ट प्रॉफिट जॉब है 74 J7. डेडलाइन है 4. इज इट अकोमोडेटेबल? हाँ, एनी स्लॉट लेस देन और इक्वल टू 4. तो J7 को यहाँ पे पाइवोट करेंगे. इसके बाद नेक्स्ट हाईएस्ट प्रॉफिट जॉब है J6. उसकी डेडलाइन कितनी है? 5. मैक्सिमम स्लॉट इज दिस फॉर J6. यहां पर पाइवोट कर देंगे. फिर उसके बाद नेक्स्ट हाईएस्ट प्रॉफिट जॉब है 52 J2. डेडलाइन 4. मतलब एनीथिंग लेस देन और इक्वल टू 4, एनी स्लॉट लेस देन और इक्वल टू 4 अवेलेबल. हाँ, J2 यहां पर फिक्स अप करेंगे. फिर इसके बाद नेक्स्ट हाईएस्ट प्रॉफिट जॉब देखिएगा 34 J3. डेडलाइन 5. एनी स्लॉट लेस देन और इक्वल टू 5. हाँ, यहां पर है 1 2 3 J3. सो बॉयज एंड गर्ल्स, दिस इज माय डेटा सेट. ये है मेरा शेड्यूल. J1 J2 J7 J4. J1 J2 J7 J4. J1 कहां पर आया? J1 क्यों आया? तुलिका, why J1 has come? So I have included this 1 2 3 4 5 jobs. J1 will not come. It is based on every Shriji Mohanty. Every job take 1 unit of time. That's why the blocks are 1 unit. Every job take 1 unit of time. That's why the blocks are 1 unit. Yes, Tulika, now you are right. 32746. 32746. So corresponding to this, the profit जो भी हो आप कर लें. हाँ, ठीक है तुलिका, no issue. So boys and girls, please tell. 310 is correct. The profit, final profit 310 है इसका. 310, वेरी गुड. चलिए आगे बढ़ेंगे. इसका भी क्वेश्चन अगर हो आगे हम देखेंगे प्रैक्टिस क्वेश्चन में. इसके टाइम कॉम्प्लेक्सिटी अगर मैं आपको बात करूं, दिस विल वर्क लाइक इंसर्शन सॉर्ट. तो हमेशा याद रखिएगा, टाइम कॉम्प्लेक्सिटी ऑफ जॉब सीक्वेंसिंग विद डेडलाइंस विद इंसर्शन सॉर्ट अप्रोच इज ऑर्डर ऑफ n स्क्वायर. तो वी हैव ब्रॉट डाउन द कॉम्प्लेक्सिटी फ्रॉम ब्रूट फोर्स ऑर्डर ऑफ 2 power n टू ऑर्डर ऑफ n स्क्वायर. ऑर्डर ऑफ n स्क्वायर याद रखिएगा. टाइम कॉम्प्लेक्सिटी ऑफ एवरी ग्रीडी प्रॉब्लम यू शुड रिमेंबर. टाइम कॉम्प्लेक्सिटी ऑफ एवरी ग्रीडी प्रॉब्लम प्लीज रिमेंबर इज ऑर्डर ऑफ n स्क्वायर. चलिए नेक्स्ट प्रॉब्लम है ऑप्टिमल मर्ज पैटर्न्स. नेक्स्ट प्रॉब्लम है ऑप्टिमल मर्ज पैटर्न. इट इज रिलेटेड टू, ये जो प्रॉब्लम है इट इज रिलेटेड टू मर्जिंग ऑफ फाइल्स. जैसे मर्ज सॉर्ट में मर्ज प्रोसीजर था वो एग्जैक्टली सेम. मर्जिंग ऑफ फाइल्स, यहां पे मर्जिंग ऑफ फाइल्स, सॉर्टेड फाइल्स, मर्जिंग ऑफ सॉर्टेड फाइल्स. तो प्रॉब्लम सिंप्लीफाइड वे में एक्सप्लेन करने की कोशिश करूंगा. इसके बेसिस पर एक एप्लीकेशन भी है, स्टैंडर्ड एप्लीकेशन, जिसका नाम है हफमन कोडिंग. वो भी हम देखेंगे. ठीक है, तो सबसे पहले मैं आपको यहां पर बताता चलूं, सुनिएगा. द प्रॉब्लम इज गिवन a set of n files. It is required to merge them. It is required to merge them using two-way merge. Two-way merge to get a single sorted file. To get a single sorted file. ये मेरा प्रॉब्लम डेफिनेशन है. This is my problem definition, boys and girls. Using 2A merge, हमें merge करना होगा n sorted files to get one single sorted file. We are given n sorted files. We are required to merge them to get a single sorted file. तो सुनिएगा, अगर दो फाइल्स हो, सुनिएगा मर्जिंग ऑपरेशन क्या है. File 1 having the following records 3, 4, 8, 10. File 2 has got records like 7 and I have 9, 15, 18, 20, something like this. 2A merging you already know. We are going to use two pointer concept. We will initialize two pointers I and j pointing to the first record. ठीक है? Compare the record 3 and 7. 3 is small. You copy 3 here. This is called record movement. This is called record movement. ये हमारा मेट्रिक है. मर्ज सॉर्ट में हमारा मेट्रिक था कंपैरिजन. अब यहां पर कंपैरिजन नहीं है, रिकॉर्ड मूवमेंट. मूविंग द रिकॉर्ड फ्रॉम वन फाइल टू अनदर फाइल इज ए टाइम कंज्यूमिंग ऑपरेशन. निशु कुमार, आप कंफ्यूज हो रहे हो. कंपैरिजन्स की बात नहीं हो रही है, रिकॉर्ड मूवमेंट्स की बात होगी यहाँ पे. हाउ मेनी रिकॉर्ड्स आर मूव्ड? 3, 7 में एक रिकॉर्ड हुआ. फिर 4 रिकॉर्ड मूव करोगे आप, फिर 7 मूव करोगे, फिर 8 मूव करोगे, एंड लाइक दैट लास्ट में 20 मूव होगा. So my question is for merging these two files. If this file has n records, this file has m records. Total record movements कितना बनेगा? Total record कितने move होंगे? Total record movements is equal to n plus m. Comparisons की बात नहीं हो रही है, record movements. I'm repeatedly saying. Copying the record from one file to another file is a basic operation है वो. So total record movements for two files is n plus m. Total number of record movements is n plus m. n plus m. समझ रहे हो? ठीक है. तो आप बोलोगे सर प्रॉब्लम तो बहुत सिंपल है. नहीं बेटा, प्रॉब्लम इज नॉट फॉर 2 files. Problem is for multiple files. So boys and girls, please observe. Suppose if I give you file 1 having, let us say, I will say like this. File 1 has, let us say, 8 records. File 2 has 3 records. And file 3 has 6 records. Records नहीं दिए गए हैं, number of records हैं. File 1, again I repeat, file 1 has got 8 records, file 2 has 3 records, and file 3 has 6 records. File 3 has 6 records. हमें इसे मर्ज करना होगा, 3 फाइल्स को मर्ज करके एक फाइल बनाना होगा. That will have how many records? 8 plus 6, 14, 14 plus 3, 17. तो मर्ज आप हमेशा 2-way मर्ज करोगे, 3-way मर्ज नहीं कर सकते, मल्टी-वे मर्ज नहीं कर सकते. So point is, suppose for example, if I merge file 1 and file 2, एक पैटर्न है, file 1 and file 2. File 1 and file 2 अगर हम मर्ज करेंगे, file 1 has got 8 records, file 2 has got 3 records. इन दोनों को मर्ज करने से मुझे एक फाइल बनेगी with 11 records. I will get a file with 11 records, 8 plus 3. अब इसके बाद I will merge. Now these two files are eaten away. मेरे पास ये टेम्पररी फाइल है, ये फाइल 3 है. फाइल 3 और टेम्पररी फाइल को मर्ज करेंगे. फाइल 3 हैज गॉट 6 रिकॉर्ड्स. हमें फाइनल फाइल बनेगी विद 17 रिकॉर्ड्स. तो टोटल, दिस इज माय व्हाट इज कॉल्ड मर्ज ट्री, 2-way मर्ज ट्री. These are external nodes, these are internal nodes. Number of record movements is given by 11 plus 17. ये मेरा फर्स्ट मर्ज ऑपरेशन था, सेकंड मर्ज ऑपरेशन है. फर्स्ट मर्ज में 11 रिकॉर्ड्स, सेकंड में 17. टोटल रिकॉर्ड्स बने 28. फॉर विच पैटर्न? F1, F2, F3. मेरा पैटर्न है 1, 2, 3, 1, 2, 3. अगर मेरा पैटर्न 1, 2, 3 है तो नंबर ऑफ रिकॉर्ड मूवमेंट्स आर 28. तो आप बोलोगे सर नंबर ऑफ रिकॉर्ड मूवमेंट डिफर होंगे फॉर डिफरेंट पैटर्न. जरूर डिफर होंगे. चलिए देखते हैं. we will try to see how the number of record movements can vary for different pattern. Like for example, boys and girls, if I merge file 1 and file 3 first, अगर दोनों को merge करूंगा 8 and 6, so I will get how many records? I will get 14 record file with 14 record movements. इसको मैं merge करूंगा with file 2. File 2 has got how many? 3. ये दोनों को merge करने से मेरी final file बनेगी again 17. Total record movements are 14 plus 17. 14 plus 17 is equal to 31. 31 and 28 different. So different patterns will have different record movements. अगर मैं 1, 2, 3 merge करा तो एक है, 2, 3, 1 merge करा तो एक है, 3, 1, 2 merge करेगा तो और एक number of record movements बनेंगे. So different patterns. This pattern is 1, 3, 2. Look at that. 1, 3, 2. 1, 3, 2. So boys and girls, my first question as usual. Let me see who will answer. What is the size of solution space of this problem? What is the size of solution space of this problem? Tulika, Aditya, Nishu Kumar, Sufia Ahmed, please tell what is the size of solution space of this? यश बेदी, आप, मैं स्ट्रैटेजी से पहले आपको पूछ रहा हूं ये प्रॉब्लम का साइज ऑफ सॉल्यूशन स्पेस क्या है? साइज ऑफ सॉल्यूशन स्पेस इज वेरी गुड, n फैक्टोरियल. n फैक्टोरियल. दैट मींस अगर ये प्रॉब्लम को हम ब्रूट फोर्स से सॉल्व करने की कोशिश करेंगे तो उसकी कॉम्प्लेक्सिटी बनेगी ऑर्डर ऑफ n पावर n, ऑर्डर ऑफ n पावर n, सुपर एक्सपोनेंशियल टाइम. सो देयरफॉर इट इज नॉट डिजायरेबल टू गो विद ब्रूट फोर्स. तो ग्रीडी स्ट्रैटेजी क्या होगी? What will be the greedy approach? Greedy approach is take the two smallest files so that the number of record movements is minimum at every step. Take the two smallest files at every step. Take two smallest files at every step so that the number of record movements is minimum. ये ideal greedy strategy है. तो ये प्रॉब्लम को सॉल्व करने के लिए पहले आपको मर्ज करना होगा F2 F3. मैं यहां पर कर रहा हूं. F2 F3 को मर्ज करना होगा. F2 और F3 को मर्ज करना होगा. F2 has 3 and F3 has 6. 3 and 6. To get one file with how many records? 9. That has to be merged with F1. F1 has how many? 8. 9 plus 8, 7, 17. Okay? This is F1. So my pattern is 231. 231. So total number of record movements, देखिएगा यहाँ पर. Total number of record movements are 17 plus 9, 26. ये है minimum. No other pattern will give you number of record movements less than 26. Less than 26. ये है प्रॉब्लम. तो चलिए एक एनलार्ज डेटा सेट दूंगा मैं आपको और आपने उसे वर्कआउट करना है. कम ऑन बॉयज एंड गर्ल्स, लेट्स से आई गिव n is equal to 8 files, F1 to F8, and their number of records. The number of records in them are given like this: 4, 8, 12, 3, 6, 5, 1, 2, 3, 4, 5, 6, and then I have 10. 7 and 4. 4 is already there. 5 we will take. 5 is also there. Let's take maybe 9. Come on, do it. Work out this problem and let me know the answer, boys and girls. Work out this problem and let me know the answer. 8 files are there. Number of records in each file is given. 1, 2, 3, 4, 5, 6, 7, 8 files. File 1 has 4 records. File 2 has 8 records. File 3 has 12 records, and so on. Tell me how many minimum number of record movements are involved for this data set. Minimum number of record movements involved for this data set. 2 mark question. ये है 2 mark question, boys and girls. Please work out as a matter of practice. $57 नहीं होगा विकास राज. विकास राज, it won't be 57. Sachin is saying 200. So at every step I have to take the 2 smallest. So 2 smallest files are 3 and 4. 3 and 4. So I will take away 3 and 4. File 4 and file 1. Merge them. 7. So 3 and 4 are eaten away, consumed. So yes, 7 you will add it to the list and take the 2 smallest. 2 smallest कौन से होंगे? 5 and 6. 5 and 6 will be the 2 smallest. 5 and 6. So 5 is 6 and 6 is 5. So these two are merged to get a file with 11 records. 11 will be added here. 5 and 6 are eaten away. 11 will be added. Next 2 smallest, 7 and 8. देखिएगा 8, 9, 10, 12. मतलब 7 and 8. So I will put 8 here. 8 is F2. So these two are combined. 15, So 8 is also eaten away. 15 is added to the list. अब इसके बाद next two smallest देखिएगा. अब मेरे 5 है 11, 15, 12, 10 and 9. So 9 and 10 are smallest. 9 and 10 are smallest. So 9 and 10 को merge करेंगे. 9 and 10. So this is F7, F8. So these two are merged to get 19. So these two are eaten away. So boys and girls, I have 12, 15 and 19. 12, 15, 19. So 12 will be merged with 15. 12 will be merged with 15. 27. 27. 12 is also gone. Now I have only these two files, 27 and 19. So 19 को आप left पे ला लीजिएगा. Smaller will always be to the left. So follow this algorithm. So 9 and 10. ठीक है? So this is F7, F8. These two are merged. So क्या बनेगा? 46. 46. So total number of record movements is given by the sum of all internal nodes. This plus this plus this plus this plus this plus this. अच्छा 11 and अच्छा 11 को हमने छोड़ दिया. You forgotten 11 ना? 11 with 12. I think I made a mistake. 11 has been left out. Yes, 11 and 12 should have been merged. There is a mistake here. I did a mistake, boys and girls. आवाज नहीं रहने से प्रॉब्लम होगा. Again, I will have to do. So you have to be careful in the exam while observing it. So again, I do no issue. 3 and 4 first. 3 and 4, 7. So 3 and 4, then 7 is gone. Then I have to add 5 and 6. 11. 5 and 6 are also gone. And then after that I have to merge 7 and 8, I hope. 7 and 8. 15. So 11 and 15. So I will mark these values here. 4 is gone, 8 is gone, and 3 is gone, 6 is gone, 5 is gone. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Fine. So who are there? 9 and 10? 9 and 10? Yes. So 9 and 10. 19. So 9 and 10 also consume. So I have 12, 11, 15 and 19. So 12, 11, 15 and 19. So therefore 11 and 12 have to be merged. 11 and 12. So मुझे इसे थोड़ा हटाना पड़ेगा. Or I'll put slightly here 12, 11 and 12. Then these two are merged. 23. ठीक है? So 12 is also gone. So all are consumed now. I have 15, 23 and 19. तो हमें 15 and 19 को merge करना पड़ेगा. 15 and 19. ठीक है? So this 15 and 19 will be merged and 23 will come to its left. तो हम 23 को यहाँ पे लिख लेते हैं. 23, 11, 12, 5 and 6. 5 and 6. So let's remove this. Then 15 and 19 are merged. So this will be 34. And then 23 and 34 are merged. I hope this is correct now. This is 57. Is this okay? 11 I forgotten earlier. Is this okay? So total number of record movements is sum of all internal nodes. Sum of all internal nodes. People are saying 166. ठीक है. So this is the policy. This is the algorithm. So boys and girls, I would like to basically make a mention with regard to the time complexity of this. याद रखिएगा. The time complexity of this will depend on the implementation of the list. The time complexity will depend on the implementation of the list. And I would like to make a mention that there are two ways in which you can implement this list. There are two ways. एक approach है you can implement as a linear list. As a linear list. अगर आप linear list की तरह implement करोगे तो order of n square is the complexity. अगर आप min heap से implement करोगे, if you implement this algorithm with a min heap, then the complexity of this will be order of n log n. Please remember this 1 mark questions. This could be 1 mark questions. The time complexity of optimal merge pattern algorithm when implemented with a linear linked list order of n square, if implemented using min heap order of n log n. Algorithm देखकर आप समझ सकते हो बड़ी आसानी से, ये क्योंकि यहाँ पर अब टाइम की कंस्ट्रेंट है इसलिए मैं एल्गोरिथम नहीं लिखूंगा. I won't write the algorithm. It's very straightforward. ठीक है. Now one of the prominent application, बहुत ज्यादा versatile important application जो है optimal merge pattern का है, वो है Huffman coding. I would say at least in previous questions of GATE, not less than 5 to 6 problems were asked based on Huffman coding earlier. Not less than 5 to 6 problems, numericals. So it's a super important topic, Huffman coding. So what exactly is Huffman coding? Let me write. Huffman coding is a data encoding plus compression. Or we would say like this, encoding is done in such a way that it leads to compression of data. Encoding आप इस तरीके से करते हो कि it will lead to compression. It will lead to compression. Encoding of elements is done. Encoding of messages is done in such a way that it would lead to compression. ठीक है? So how is it done? Huffman coding is basically frequency dependent encoding. It is basically frequency dependent encoding. The straightforward encoding techniques like आप ASCII code देखो या FCD code देखो या BCD code देखो, they are non-frequency dependent. They are straightforward encoding. मतलब if I have, let us say, n elements, I need log n bits. I need log n bits. समझ रहे हो? I need log n bits for that. So with the straightforward encoding, non-frequency dependent encoding, compression is never possible. Frequency dependent मतलब जो भी कैरेक्टर की फ्रीक्वेंसी ज्यादा होगी, यू आर गोइंग टू असाइन लेस नंबर ऑफ बिट्स. जो भी कैरेक्टर और एलिमेंट की फ्रीक्वेंसी कम होगी, you assign more number of bits. With that approach you can achieve compression, and this compression leads to always optimization, frequency dependent encoding. ठीक है? So how is it done? This assignment of codes is done purely, as an algorithm of optimal merge pattern. तो एक एग्जाम्पल लेकर समझते हैं how is it done, so that we can take later the realistic problems also which were asked in earlier papers. Let us say I have some language with the following characters A, B, C, D, E. Let's say some frequencies are given 0.23, 0.05, 0.42, 0. Let's say 13. So let us calculate 0.23, 0.05, 0.42, 0.13, 10, 13, 2, 3, 4, 8, 0.8, मतलब 0.17. चलिए ठीक है, 0.17. These okay. Boys and girls, this is my data set. अब आप यहाँ पे देखिएगा, this character is having highest frequency, this character is having lowest frequency. So I should have variable number of bits. I should have variable number of bits per character. So how are we going to achieve this? Simply I have to construct a two-way merge pattern tree as we did in optimal merge pattern. तो ये frequencies का optimal merge pattern encoded tree बनाइएगा, encoding tree. कैसे करेंगे? Same optimal merge pattern algorithm. Take the two smallest frequencies, 0.05, 0.13. यहाँ पे लेंगे, देखिएगा 0.05, 0.13. Merge them as usual, optimal merge pattern algorithm. 0.18, add it to the list. Take the next two smallest क्या होगा? 0.13, 0.05 over 0.17, 0.18 and 0.17. Smaller value should always be to the left. 0.17 and 0.18 are merged. So that will give you how much? 0.35. 0.35 is added to the list. तो अब देखिएगा 3 elements are over, 0.05, 0.13 is over, 0.17 is also over. I have next 0.23, 0.35, 0.42. So 0.23 is smallest. So 0.23 and 0.35 are merged. 0.23 and 0.35 are merged. This will be 8 and 0.58. 0.58. Then 0.58 is merged with 0.42. 0.42 एक remaining है. So 0.42 is smaller. So 0.42 will come to the left. So merge these two. Root will have 1.0 provided sum of all frequencies is 1. So this is the tree that I got by applying the optimal merge pattern algorithm. अब यहाँ पे हमें एक convention follow करना है. All left branches, left edges of the tree will be marked 0. Right edges will be marked as 1. That is the general convention followed in almost everywhere. So left branch 0, right branch 1, left branch 0, right branch 1, left is 0, right is 1, left is 0, right is 1. Let us mark 0.05 is this is the frequency of character B. Then 0.13 is the frequency of A, B, C, D. 0.17 is E. 0.23 is A. 0.42 is C. So therefore, the code of character A, is 10. The code of character B is 1110, and the code of character C is 0. The code of character D is 1, 2, 3, 4. 1, 2, 3, 4. The character E 110, 110. So how many bits? This is 2 bits. This is how many? 4 bits. This is 1 bit, and this is 4. These 3. Non-uniform encoding. Frequency highest है 1 bit. Frequency lowest है 4 bits. Frequency dependent encoding. And boys and girls, another important property of Huffman code is that all Huffman codes are prefix codes. All Huffman codes are prefix codes, boys and girls. Does anybody know? Can you write, those who know, what is the meaning of prefix code? देखेंगे कौन बताएगा. Prefix code का मतलब क्या है? क्योंकि एक गेट क्वेश्चन पूछा गया है based on prefix code. So if you don't know the meaning of prefix code, you will have a problem. बोलिए. निशु कुमार, तुलिका, प्रीफिक्स कोड का मतलब क्या है? प्रीफिक्स कोड का मतलब क्या है? Anyone? Mr. Eigen 7659. Nishu Kumar, Eigen. Yes. No code will be a prefix of other. No code will be a prefix of other. आपको नेटवर्किंग में भी ये कॉन्सेप्ट यूज होता है, सुपर नेटिंग, सब नेटिंग में. ठीक है. प्रीफिक्स का मतलब ये है कि no two codes will have the same prefix. मतलब ये है, देखिए, ये कोड है 10, मतलब अब कोई भी कोड में 10 नहीं आएगा. देख लीजिएगा आप. There is no 10 here in the prefix in the beginning. There is no 10. There is no 10. No. ये कोड है 0. There is no code with starting with 0. 1110, there will never be anything. 110 देखिएगा, 110 कहीं भी नहीं आएगा as a prefix. ये है प्रीफिक्स कोड. इसका मतलब है प्रीफिक्स कोड. चलिए, ठीक है. तो अब ये देखिएगा, एवरेज नंबर ऑफ बिट्स पर कैरेक्टर इज गिवन बाय व्हाट? एवरेज नंबर ऑफ बिट्स पर कैरेक्टर. एवरेज नंबर ऑफ बिट्स पर कैरेक्टर इज गिवन बाय वेटेड एक्सटर्नल पाथ लेंथ सिग्मा DI QI. ये फॉर्मूला है. वेटेड एक्सटर्नल पाथ लेंथ आपने डेटा स्ट्रक्चर्स में पढ़ा होगा. वेटेड एक्सटर्नल पाथ लेंथ ऑफ ए ट्री, बाइनरी ट्री, sigma DI QI. What is DI? Distance from root to message I. QI is frequency, the frequency or the probability of that message. अगर ये फॉर्मूला को मैं यहाँ पे एक्सपैंड करूं, D1 डिस्टेंस फ्रॉम रूट टू मैसेज 1 2 कैरेक्टर्स, इसकी फ्रीक्वेंसी है 0.23 प्लस D2 4 into its frequency is 0.05. D3 is 1 into its frequency 0.42 plus D4 is 4 into its frequency 0.13 plus D5 है 3 into its frequency 0.17. This is the average number of bits per character. Average number of bits is weighted average. It is not simple average. Simple average का मतलब 2 plus 4 plus 1 plus 4 plus 3 divided by 5. Simple average नहीं है, weighted average. Average number of bits is always given by weighted average. Please remember, काफी important point है. Very important point, weighted average. Tell me what is the answer for this? Dipanshu Kumar. Good evening. Nishu Kumar, बोलिए, what is the answer for this? What is the answer for this, boys and girls? Simplify करने पर क्या बनेगा value, so that we can tell, we can see how it is compression. ये compression कैसे होगा? Come on, boys and girls. 3.49. How can it be? Rishabh Keshari, no, it cannot be 3.49. Check it. Rishabh Keshari. 2.11. ठीक है, maybe 2.1 correct. 2.11 bits per character, weighted average. 2.11 bits per character. तो अगर आप नॉन फ्रीक्वेंसी डिपेंडेंट या स्ट्रेट फॉरवर्ड अप्रोच से जाते, नॉन फ्रीक्वेंसी डिपेंडेंट स्ट्रेट फॉरवर्ड एनकोडिंग पे जाते, आई हैव 5 कैरेक्टर्स, so that will require 3 bits per character. Straight forward encoding, 3 bits per character. So I say that I have reduced from 3 bits per character to 2.11. Therefore it is compression. Therefore it is compression. I have reduced from 3 bits per character to 2.11 bits per character. And you can even take some text. You can even take some text and see the difference. Suppose if I take a text like, for example, C, 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 A, E, and B. This is my text. So what will be the code that will be transmitted? That will be the code, how this will be encoded. C का code क्या है? 0, 0, 0. A का code क्या है? 1, 0. E का code है 1, 1, 0. B का code है 1, 1, 0. So total how many bits are used? 2, 4, 6, 8, 10, 12. 12 bits. अगर स्ट्रेट फॉरवर्ड एनकोडिंग आप जाते तो I have how many characters? 1, 2, 3, 4, 5, 6 characters. 6 into 3, 18 bits would have required. Straight forward encoding 3 bits per character, 6 elements, 6 into 3, 18 bits, 12 bits. So it has reduced from 18 to 12 bits compression. It has reduced from 18 to 12 bits compression. ये है Huffman coding, boys and girls. We'll see problems of this shortly after completing all the topics of this. All the topics of this. ठीक है, तो ये है, चलिए बच्चों, Huffman coding is an application. Next important problem of greedy method is spanning tree, and overlapping topic जो आप discrete mathematics के graph theory में भी पढ़ते हो. ठीक है, मुझे समझाने की जरूरत नहीं है कि what is spanning tree. A subgraph such that it maintains connectivity, that is called basically spanning tree. Covering up all the edges, all the vertices of the graph is basically a spanning tree. It's a very super important topic because there are many real life applications which are based on spanning tree. So if you want me to write the formal definition of spanning tree, a subgraph by name T with V comma E dash of what? Of the given graph G, V comma E, where E dash is a subset of E. This subgraph is a spanning tree. This subgraph T is a spanning tree. If and only if T is a tree. T is a tree. By saying it is tree, we are trying to say that it is acyclic. And it will have n minus 1 edges, where mod V is equal to n and mod E is equal to E. Number of vertices are n, number of edges are E. Number of vertices are n, number of edges are E. V is the vertex set, E is the edge set. The edges that are used in the construction of spanning tree are the edges present in the graph. You cannot take a new edge because E dash is a subset of E. E dash is a subset of E. One simple question is number of edges that must be removed. That must be removed from the graph. To get a spanning tree. To get a spanning tree is equal to dash. If the graph has n vertices and E edges, how many edges must be removed from the graph to get a spanning tree? The number of edges that must be removed from the graph is given by E minus n plus 1. E minus n plus 1, correct? Yes. The number of edges that must be removed from the graph to get a spanning tree is e minus n plus 1. ठीक है, अब यहाँ पे डायग्राम में देखिएगा प्लीज, दिस माय ग्राफ, कंप्लीट ग्राफ, generally spanning trees for undirected graphs, weighted graphs. So these one spanning tree, another spanning tree, another spanning tree, and I don't have to tell, everybody is knowledgeable. What is the size of solution space of number of spanning trees? Solution space, बोलिएगा. How many spanning trees are possible for a given graph with n vertices? Maximum. Ajit Sharma, Tulika Datta, Nishu Kumar, Yash Bedi, please tell. How many spanning trees maximum are possible for a given graph with n vertices? Maximum कब होगा? When the graph is complete. When the graph is complete. For example, I have a kn graph. If I have a kn graph, बोलिए, if I have a kn graph, then what is the number of spanning trees possible for a given graph having n vertices? Complete graph with n vertices. Cali's formula, n power n minus 2. Remember this. मतलब यह है, अगर आप enumerate करोगे n power n minus 2, the solution space n power n minus 2, complexity will be order of n power n, super exponential. Complexity बनेगी super exponential अगर आप brute force से solve करने की कोशिश करो. The concept of cost will come into picture when the graph is weighted graph. अगर weights हो, the sum of the weights of the edges present in the tree is the weight of the spanning tree, cost of the spanning tree. The sum of the weights of the edges present in the graph in the spanning tree is the weight of the spanning tree, cost of the spanning tree. There are many real life applications of minimum cost spanning tree in networks, in power system design, and maybe many other power systems and transportation systems and so on. There are many applications of minimum cost spanning tree. So boys and girls, इसका objective ये है to construct, see the algorithms which are there for greedy based algorithm for construction of minimum cost spanning tree. There are two popular algorithms, आपको पता है, Prim's method and Kruskal's method. But I also teach as one more method called Dijkstra. हालांकि Dijkstra people think it is only for shortest path. No. Dijkstra we have for spanning tree also, right? But there are certain important properties of spanning trees. Like for example, अगर graph में all distinct edges हो, distinct weight edges हो, then spanning tree will always be unique. Then there is a cycle property of spanning tree, right? In every cycle, for example, while construction of the spanning tree based on Dijkstra's algorithm, whenever you encounter a cycle, you will remove the edge with the highest weight. That is called cycle property. और एक property है cut property, CUT, cut property of spanning tree. Does anybody know what is a cut property of spanning tree? Can you write down? स्वास्थी करने क्या? स्वास्थी कनायक. The procedure for finding the number of spanning trees. The procedure for finding the number of spanning trees for a non-complete graph. Non-complete graph is a method which is called cofactor of a matrix. अगर आपको पता है cofactor of matrix, then you can basically do it. Diptanshu Kumar, I will discuss at the end what are the important topics to focus from my end. मेरे हिसाब से कौन से टॉपिक्स इंपॉर्टेंट होंगे मैं लास्ट में आपको बताऊंगा, आप फॉलो कीजिएगा लेक्चर, ठीक है? सो बॉयज एंड गर्ल्स, आई वाज आस्किंग व्हाट इज अ कट प्रॉपर्टी ऑफ अ स्पैनिंग ट्री. Cut property of spanning tree. If you have studied about cuts in graph theory in discrete mathematics, then basically you will come to know what is cut property. Cut is basically a partition of the graph. Yes, that is correct. Cut is basically a partition of the graph. मतलब set of vertices को आप divide करोगे two parts में, that is called a cut, so that there is no vertex in common. Then there may be many edges passing through the cut. The edge with minimum cost, boys and girls, if the edge with minimum cost in the cut will always be part of spanning tree, minimum cost spanning tree. If every cut is joined by unique edge, then graph has a unique spanning tree. Okay, I am talking about edge cut, so not vertex cut. The cut properties say that the least cost edge passing through the cut will always be part of spanning tree. Least cost edge. ये प्रॉपर्टी के बेसिस पर क्वेश्चन पूछे जा चुके हैं पहले, तो आपने याद करना है, आपने रिमेंबर करना है. अगर आपको पता नहीं है तो सबसे पहले आप ग्राफ थियरी में कट क्या है समझना है. व्हाट इज अ कट? कट इज अ पार्टीशन you are going to divide the vertex set into two parts in such a way that one set of vertices is at one side, the other set is at the other side, and all the some edges will pass through the cut. Yes, Kunal Kumar, that's correct. And the minimum, there may be many edges passing through the cut, the set of vertices this side, the set of vertices the other side. The edge with the least cost will always be part of spanning tree. That is called cut property. So spanning tree के important properties है कि, I mean, if all edge weights are distinct, unique spanning tree रहेगा. Least cost edge will always be part of spanning tree. Second least cost edge will also be part of spanning tree. Third least cost edge may or may not be part of spanning tree. Highest weight edge may or may not be part of spanning tree. Will always be part of spanning tree. अगर वो bridge हो तो part of spanning tree रहेगा. Cut property, cycle property भी हमेशा याद रखिएगा, important है. Every cycle of the graph, the edge with the highest weight will always be excluded from the spanning tree. Yes, Kunal Kumar, you have written very correct definition. Very good. Congrats. Kunal Kumar has written the definition of cut. Very good. Those who have not followed, please see that. Kunal Kumar ने definition लिखा cut का. Cut property. Yes, bridge will always be part. If bridge with whatever weight is there will always be part of spanning tree. अगर bridge का highest weight हो तो the highest weighted will also be part of spanning tree, minimum cost spanning tree. तो ये है बच्चों method. मैं quickly आपको ये देखिएगा, Robert Prim and Joseph Kruskal, the people who made contribution to the construction of the algorithms, construction of the spanning tree based algorithms. यहाँ पर मैं quickly trace करूंगा for Prim's method and Kruskal's method. So I will explain the Prim's algorithm. So I will take the skeletal structure of this graph. This vertex 1, this 2, this 3, this 7, this 6, this 5, this 4. अब ये जो कंस्ट्रक्शन है एल्गोरिथम का Prim's and Kruskal's, Prim's का जो particularly है, there are two variations. साहनी टेक्स्ट बुक का एक कन्वेंशन है एंड बेसिकली कॉर्मन टेक्स्ट बुक, CLRS टेक्स्ट बुक का अदर कन्वेंशन है. आई फॉलो साहनी कन्वेंशन which is a pure greedy approach. So based on greedy strategy, based on greedy approach, the Sahani textbook convention say that you must start when I have all the edges available. So greedy strategy क्या कहेगी? Greedy strategy कहेगी start with the edge having the least cost. So that's what Prim's Sahani textbook follow the same convention. So I'm following Sahani's convention. So start with the edge having the least cost. So in our example, the least cost edge is 1 to 6, 10. 1 to 6, 10. ठीक है? 10. Then the Prim's method say that the next edge to be added should always be adjacent from the vertices included so far. Adjacency property is always followed in Prim's method. The next edge, again I repeat, the next edge to be added in Prim is the one which is adjacent from the vertices included so far, having least cost weight, and addition of that edge should not lead to cycle. So तीन property देखना है Prim's में. Number 1 adjacency, number 2 least weight, number 3 formation of cycle. Three things have to be observed. So यहाँ पर देखिएगा, the possibilities I can add 1 to 2 or 6 to 5. These are the two possibilities. दोनों में least cost edge क्या है? 6 to 5. कितना है? 25. The addition of that will not lead to a cycle. So therefore I add with cost value 25. अब जो edges add हो, जो vertices add हो चुके हैं 1, 6 and 5. The next edge should be again adjacent. And what are the possibilities? 5, 4, 5, 7, 2, 8. So least cost क्या है? 5, 4, 22. So I add because that does not lead to a cycle. So this is 22. Next should be adjacent from either 4 or 5 or 6 or 1. Least cost and should not lead to a cycle. Possibility क्या है? 18, 12, 20, 28 and 5, 4, 24. So naturally 12 is less. So I add 12. ये है 12. फिर इसके बाद next possibility is this one or this one or this one or this one. 3 to 2 is less. So 3 to 2 is added. 3 to 2 is added with a cost value 16. फिर उसके बाद next क्या है possibility? 2 to 7 and the addition of 2 to 7 does not lead to a cycle. I add. I have a graph with 7 vertices. I need 6 edges. 1, 2, 3, 4, 5, 6 edges. So that complete the construction. ये है Prim's ideology. ठीक है? फिर उसके बाद अगर आप Kruskal's की आइडियोलॉजी देखोगे यहाँ पर Kruskal's मेथड, बॉयज एंड गर्ल्स, Kruskal method is based on maintaining the edge values in the form of a min heap. Kruskal's algorithm. Maintaining the edge values in the form of min heap. मतलब इंक्रीजिंग ऑर्डर में हीप के एडजेस को एज कॉस्ट को मेंटेन करना होगा. क्या है? 10, 12, 14, 16, 18, 22, 24, 25, 28. These are the edge values. I will take the skeletal structure of the graph. This is vertex 1, vertex 2, vertex 7, vertex 3, vertex 4, vertex 5, vertex 6. Vertex 6. So let us number these 1, these 2, this 6, this 7, this 3, and this is 4, this is 5. Edge with the least cost. Delete the least cost edge 10 and add it if it does not lead to a cycle. Yes, it does not lead to a cycle, we add. So these least cost edge with value 10. Next, delete the next least cost edge 12. 12 is present between 3 and 4. Does it lead to a cycle? No, sir. So therefore we can add with a cost value of 12. Here next 14. 14 is present between 2 and 7. Does it lead to a cycle? No. So therefore we can add 14. Next 16. 16 is present between 2 and 3. Can we? Yes, we can add. So therefore this is 16. Next is 18. 18 is present between 7 and 4. That leads to a cycle. So therefore 18 is discarded. Next we delete 22. 22 is present between 5 and 4. Doesn't lead to a cycle. So therefore we add 22 with a cost value 22. Next we delete 24. 24 is present between 7 and 5. Discarded because that lead to a cycle. Next 25. 25 is present between 5 and 6. We add, and that is the last edge to be added. That is the last edge to be added. Sixth edge 25. So these get the same tree. The final tree generated by both the approaches are same. When the edges have distinct weight, all edges have distinct weight, I will have a unique spanning tree generated by any method, Prim's method, Kruskal's method, or my method, or your method, provided it is greedy method. It will always be same. If multiple edges have same cost, then the tree structure generated by Prim and Kruskal may vary. If multiple edges have the same cost, then the tree structure generated by Prim and Kruskal may vary because I may have cycles. So this is the approach. और मैं आपको ये बताता चलूं, अगर टाइम कॉम्प्लेक्सिटी की बात करोगे आप, ट्रेडिशनल इंप्लीमेंटेशन इज ऑर्डर ऑफ n स्क्वायर विदाउट हीप. अगर आप हीप बेस्ड इंप्लीमेंटेशन करोगे, टाइम कॉम्प्लेक्सिटी इज गिवन बाय n plus e log n. n is the number of vertices, e is the number of edges, n plus e log n. And time complexity of Kruskal method direct heap based है ये, order of e log e, where e is the number of edges, n is the number of vertices. ये याद रखना है. Time complexity of Prim's method and Kruskal's method. Time complexity of Prim's and Kruskal's method. Is it okay? चलिए नेक्स्ट. और एक ग्राफ बेस्ड प्रॉब्लम है, डाइकेस्ट्रास एल्गोरिथम फॉर सिंगल सोर्स शॉर्टेस्ट पाथ. शॉर्टेस्ट पाथ्स इन ग्राफ की बात करोगे आप तो बेसिकली देयर आर मल्टीपल एल्गोरिथम्स. एक प्रॉब्लम है सिंगल सोर्स शॉर्टेस्ट पाथ्स, दूसरा प्रॉब्लम है ऑल पेयर शॉर्टेस्ट पाथ्स. सिंगल सोर्स शॉर्टेस्ट पाथ्स वी वांट टू फाइंड द शॉर्टेस्ट पाथ फ्रॉम अ सिंगल वर्टेक्स टू ऑल अदर वर्टिसेस. इट इज लाइक ब्रॉडकास्टिंग कॉन्सेप्ट, ब्रॉडकास्ट. All pair shortest path, you find shortest path from for every pair of vertices. और ये प्रॉब्लम ऐसा है, all pair shortest path you can solve using greedy method and dynamic programming both. You can solve it by using greedy and dynamic both. ठीक है, तो सुनिएगा प्लीज. For single source shortest paths there are two algorithms. One is Dijkstra, the other is Bellman-Ford. Dijkstra algorithm always work with positive weight edges. And if the graph has both positive and negative or negative weight edges, then Dijkstra algorithm may or may not work. Please follow these advices. If the graph has positive and negative weight edges both mixed together, then Dijkstra may or may not work. And Bellman-Ford will always work. Bellman-Ford is based on dynamic programming. Bellman-Ford will always work. But it will work only if the graph has no negative weight cycle reachable from source. The graph has no negative weight cycle. Negative weight cycle अगर ना हो तब वर्क करेगा, because no algorithm can work with negative weight cycle. No algorithm can work with negative weight cycle. Please remember that. क्योंकि डिटेल में हमने क्लास में डिस्कस किया था, those who attended my class can understand. No algorithm practically can work with negative weight cycles reachable from source. And lastly, with positive and negative weight edges, all pair shortest paths can work with Floyd-Warshall's algorithm, which is also based on dynamic programming. तो अब सबसे पहले हम देखने की कोशिश करेंगे the algorithm of single source shortest path Dijkstra's algorithm. How does it work? Based on greedy strategy. Based on greedy strategy. So this can work. मेरे हिसाब से, I mean, मेरा interpretation है कि मैं अपनी terminology में कहता हूँ कि essentially there are two ways of interpreting this. One I call from my side as matrix method, and the other I call it as spanning tree method. Here I will mark the d values of the vertices, distance values from source. So first I will put all the vertices 1, 2, 3, 4, 5, 6. So here in the first column I said vertex selected. The whole crux of Dijkstra's algorithm is based on computing d values with relaxation process. Computing the d values with a relaxation process. So how is this done? Any vertex can be the source. I can select vertex 1 as source, for example. I can select vertex 1 as source. तो सबसे पहले हम क्या करेंगे? We will initialize the d values to those vertices which are directly adjacent from 1. कौन से vertices adjacent from 1 हैं? 2 and 4 and 3. So 2 is reachable at a cost of 50. 1 to 1 there is no meaning. Cut of cost of 50. 3 is reachable at a cost of 45. 4 is reachable at a cost of 10. There is no edge from 1 to 5. There is no edge from 1 to 6. So infinite. Infinite का मतलब है as of now I don't know any cost to vertex 5 to vertex 6 from 1. So please observe. This greedy approach. Greedy methods say that out of all available options, select that option which satisfies your objectivity. मेरा objectivity क्या है? To minimize the cost. So I should select that vertex which is not selected having the least d value. D value क्या है? The cost of reaching that vertex from source. The cost of reaching 2 from source is 50. The cost of reaching 3 from source is 45. From 4 to 4 is 10. To 5 is infinite. Means I don't know. So देखिएगा. So who will get selected? This value is least. So vertex 4 is getting selected. So I will add vertex 4 to my list. After the addition of this vertex, quite possible that the d values to the unselected vertices may change. तो unselected vertices क्या है? 2, 3, 5, 6. तो d value of vertex 2 may change. कैसे? Earlier direct edge cost was 1 to 2. Now I can think, can I reach from 1, 4 to 2 via 1, 4, 2? So I should look at the graph. Do I have a path 1, 4, 2? No, I don't have. So I don't relax this value. This will remain for 50. Similarly, I should see, do I have a path like 1, 4, 3? No, I don't have. So this value will also be 45. No change. 10 is final. We don't change. ये final हो गई है. We don't change. 5, I was not having a direct edge from 5, from 1 to 5. But can I reach 5 via 4? 1, 4, 5. Yes, I have a path. Total cost क्या होगा? 10 plus 15, 25. 25 is lesser than infinity. So relax. So this process is called relaxation. Whenever I find a better path, I relax the d value. This process is called relaxation. So the value of 5, vertex 5, infinity got relaxed to 25. 6 is not reachable infinite. Then in the next step, we will basically select that vertex which is having the least d value. Among the unselected vertices, select that vertex which is having the least d value. ये देखिएगा 50 है, 45, 25. 5 is not selected, so select 5 with the value 25 and add it to the list. तो यहाँ पर हम add करेंगे 1, 4, 5. Again, I carry out the relaxation to the unselected vertices. Can I have a better path of reaching 2 from the set 1, 4, 5? 1, 4, 5, 2. Cost कितना बना? 10, 15, 20. 10, 15, 20, 45. 45 is better than 50. So relax. So ये relax हो गया 45. 1, 4, 5, 3 path है लेकिन cost बढ़ के 45 से. No change. This is already done. ठीक है? ये है infinity. In the next step, directly 15, Nishu Kumar. Next step, same thing. Repeat करना है वही. Unselected vertices. Select the one having the least d value. Maybe I select 2. So I will add 1, 4, 5, 2. Then I check for relaxation. This is already done. 1, 4, 5, 2, 3. No better path. So 45 itself. 10, 25. Once a vertex is selected, its d value cannot change. So this is final, this is final, this is final, and last I would select this 45. Last I would select this 45, and that will be my final answer. That will be my final answer. So final costs of the paths from vertex 1 to all other vertices are here. 1 to 2 is 45, 1 to 3 is 45, 1 to 4 is 10, 1 to 5 is 25, 1 to 6 is infinity. At the end last iteration में अगर कोई vertex की value infinity आ रही है तो इसका मतलब ये है कि that vertex is not reachable from source. देखिएगा 6 is not reachable from 1. There is no integrity to 6. So therefore these are the shortest path values. ये है Dijkstra's algorithm और इसका जो performance है it is exactly similar to Prim's. So therefore time complexity is order of n square and with heap implementation it is order of n plus e log n log e log n order of n plus e log n. ये है performance of Dijkstra's algorithm. ठीक है, तो चलिए quickly we'll take up some questions as a matter of practice. First question, boys and girls, simple question है, Knapsack का प्रॉब्लम है, 2 mark गेट क्वेश्चन. देखेंगे कौन बताएगा आंसर. कम ऑन बॉयज एंड गर्ल्स, प्लीज वर्क आउट एंड टेल. Come on, what is the answer for this? Zero. Binary knapsack, greedy knapsack का क्वेश्चन है, 2 mark का न्यूमेरिकल क्वेश्चन है. Nishu Kumar, no, that's not correct. Nishu Kumar. डेटा रॉन्ग है. आई डोंट थिंक इट इज रॉन्ग. अच्छा ठीक है, ओके, वर्कआउट विथ डेटा. ठीक है, डेटा गेट के एग्जाम के हिसाब से रॉन्ग होगा, बट इवन देन यू कैन टेल. आई डोंट थिंक इट इज रॉन्ग. यस, 16 correct answer. I think V opt is what? Without any approach, you can directly say the weight of the knapsack is 11. So highest profit will never be more than 60. Highest profit will never be more than 60. Highest profit will never be more than 60. V greedy के लिए you have to go for PI by WI ratio. PI by WI ratio. So what is PI by WI? 60 by 10, 6. 28 by this 4. 20 by 4, 5. ये बनेगा 12. So V greedy के लिए first object to go will be object 4 with a weight of 2. इसके बाद next highest object, object 1 cannot go, you cannot split the object. Next highest object is object 3. Can it go? हाँ sir, it can go because this is 5. So दोनों आ सकता है, फिर उसके बाद second is ignored. So the final profit is 20 plus 44, 44. 60 minus 44 is equal to 16. So correct answer is C. करेक्ट आंसर इज सी. चलिए नेक्स्ट क्वेश्चन, सिंपल क्वेश्चन है, जल्दी आंसर बताइएगा. ऑप्टिमल मर्ज पैटर्न का क्वेश्चन है बॉयज एंड गर्ल्स. ऑप्टिमल मर्ज पैटर्न का क्वेश्चन है, जल्दी बताइए. ऑप्टिमल मर्ज पैटर्न का क्वेश्चन है, जल्दी फास्ट. दीज आर प्रैक्टिसिंग क्वेश्चंस. नंबर ऑफ रिकॉर्ड्स है, मर्ज करना है, 2 to 2 smallest and give me the answer which is correct. A, B, C, D. So you will have to merge 5 and 10. आप अपने से कीजिएगा, don't look at my solution. 5 and 10, 15, 15 and 20, 35, 30 and 30, 60, 95. देखिएगा यही ट्री आपने आपको पता आपको मिला है. Have you got the same tree? 95 plus 60 plus 35 plus 15. 95 plus 60 plus 35 plus 15. 1, 2, 3, 4. 10, 15, 10, 16, 17, 20, 205. Is it C? Vikas Raj, Sayan Datta, I don't know why you made mistake. मुझे 205 आया है. Am I right? Yes, 205 is correct. 205 is correct. Sayan Datta, देखिएगा where you have gone. निशु कुमार, D कैसे आया? निशु कुमार, how will you get D? Is it saying number of comparisons? अच्छा, number of much bad, number of record movements नहीं है, ठीक है. Number of comparisons okay. Number of record movements कर लेंगे, क्योंकि much pattern है. Number of record movements कर लेंगे. Number of record movements कर लेंगे. यहां पर मैं सेपरेटली आपको पूछूंगा नंबर ऑफ कंपैरिजंस क्या होंगे. यहां पे हम लिख लेंगे नंबर ऑफ कंपैरिजंस क्या होंगे. -1, 14. Total number of comparisons 14. Then 34, and then 55, 59, and then 94. ये number of comparisons. Is it okay? टू नॉट वन. चलिए ठीक है. नंबर ऑफ कंपैरिजन बात होगी तो वो समेशन है 9 + 4 13, 13 + 8 21, 1 कैरी 2 3 6 11 20. करेक्ट. 201 करेक्ट है. चलिए नेक्स्ट क्वेश्चन. कम ऑन. हफमन कोडिंग का है. फास्ट. बॉयज एंड गर्ल्स प्लीज वर्क आउट दिस फास्ट एंड टेल मी द आंसर. हफमन कोडिंग का क्वेश्चन है. श्रीजीत, नंबर ऑफ कंपैरिजंस फॉर मर्जिंग टू फाइल्स विद n and m records is n + m - 1. मर्ज सॉर्ट में हमने पिछले सेशन में देखा था. श्रीजीत मोहंती, नंबर ऑफ कंपैरिजंस. श्रीजीत मोहंती सुनिएगा. नंबर ऑफ कंपैरिजंस नीडेड फॉर मर्जिंग टू फाइल्स हैविंग n and m records is n + m - 1 मैक्सिमम. n + m - 1. ठीक है. yes, this will be 225. What is the average number of bits? Tulika, please tell. Average क्या बनेगा यहाँ पर? Using Huffman coding. Using Huffman coding, what is the average number of bits? 2.25. बिल्कुल सही है. 2.25. ट्री कंस्ट्रक्ट करने पर आपको मिलेगा 2.25. 2.25 into 100, 225. 2.25. चलिए नेक्स्ट. दिस इज ए स्टार क्वेश्चन बॉयज एंड गर्ल्स. जनरली यहां पर मैंने देखा है स्टूडेंट्स को थोड़ा कंफ्यूजन होता है क्योंकि क्वेश्चन में थोड़ा इंग्लिश का इंटरफेरेंस ज्यादा है और जिन बच्चों की इंग्लिश का प्रॉब्लम है ये क्वेश्चन को समझने में काफी दुश्वारी होती है. मैंने ऑब्जर्व किया है. आई डोंट नो, यू कैन जस्ट रीड इट फर्स्ट. तो इसीलिए मैं हमेशा कहता हूं इंग्लिश इज वेरी इंपॉर्टेंट पर्टिकुलरली फॉर सर्किट ब्रांच लाइक CSIT, इलेक्ट्रॉनिक्स इंजीनियर्स. सुनिएगा. बी फॉर बिहार. ठीक है. पर्टिकुलरली ये जो स्टेटमेंट है, ये स्टेटमेंट को मैंने देखा है जिसकी भी इंग्लिश जरा थोड़ा सा स्ट्रगल है तो ये समझने में प्रॉब्लम होता है बच्चों को. दे कांट अंडरस्टैंड इट. And that's the reason I always emphasize that you please focus on English. फिर भी रीड कीजिएगा क्वेश्चन. I will work out. Consider the string A, B, B, C, C, D, D, E, triple E. Every string must be assigned a binary code. For any two letters, the code assigned to one letter must not be a prefix. मतलब Huffman code. For any two letters of the same frequency, अगर दो लेटर्स की फ्रीक्वेंसी सेम है, द लेटर विच अकर्स अर्लियर इन द डिक्शनरी ऑर्डर, जो पहले आएगा, जैसा ए पहले आएगा बी से, is assigned a code word whose length is at most, मतलब not more than the length of the code assigned to the other letter. यही स्टेटमेंट है जो बच्चों को सिर घुमाता है. तो चलिए समझने की कोशिश करेंगे. हफमन कोड से ट्री बनाना है तो हम नेक्स्ट पेज पे वर्क करेंगे. A has frequency of 2, B has frequency of 2, C has frequency of 2. A की 2 है या 1 है? A की 1 है. A की 1 है, B की 2 है, C की 2 है, D की 2 है, E की 3 है. ये फ्रीक्वेंसीज है, ये देखिएगा. ठीक है. तो अब यहां पर जब आप हफमन कोड्स बनाने की कोशिश करोगे तो आई एम सपोज टू टेक द 2 स्मॉलेस्ट. अब ये देखिएगा 2 स्मॉलेस्ट कौन बनेंगे? 2 स्मॉलेस्ट कौन बनेंगे? अब यहां पर कंफ्यूजन है, सुनिएगा. कम ऑन आंसर मी बॉयज एंड गर्ल्स, इज इंटरेस्टिंग. तो सबसे पहले 2 स्मॉलेस्ट लेना पड़ेगा, नॉट हाईएस्ट, 2 स्मॉलेस्ट. तो ये तो आएगा पक्का 1. अब उसके बाद मेरे पास 3 ऑप्शंस है, बी सी डी. 2 2 2. बॉयज एंड गर्ल्स प्लीज अंडरस्टैंड, बी सी डी. तो ए के साथ या मुझे बी को कंबाइन करना है, या सी को करना है, डी को करना है, या कोई भी कर सकते हो सर, ऐसा कहोगे आप? नहीं. The letter which occur first in the dictionary should not have a length of code more than the other character. तो मतलब A ज्यादा डेप्थ में जाएगा, A सबसे ज्यादा डेप्थ में जाएगा क्योंकि उसकी फ्रीक्वेंसी कम है. तो सबसे आखिर में कौन आएगा अमंग B C D? D आएगा. D आएगा. तो D should have more length, मतलब this should be D with 2. ये दोनों को मर्ज करेंगे with 3. अब ये देखेगा ये कंज्यूम हो गया है, D भी कंज्यूम हो गया है. I will have 3 3 and 2 and 2. So therefore next B and C are going to be eaten away. B and C are going to be combined. B and C with value 2 and 2. ये दोनों को मर्ज करेंगे तो 4. तो B and C are gone. So I have D and E and this 4. So 3 3 4. So I will put this 3 here, no issue. E with value 3. ये 3 and 3 को मर्ज करेंगे 6. Then finally 4 को मर्ज करेंगे 4. Bring it here. B and C 2 and 2. तो ये हो गया है हमारा 10. ठीक है. ये हमारा करेक्ट ट्री है. ये हमारा करेक्ट ट्री है. सो 0 1 0 1 0 1 0 1. So D is having more length than B. B C D. B and C are having the same code length. So he is asking what is the total. पूछा क्या गया है? What is the minimum length of encoded string? तो इस encoded string का मिनिमम लेंथ क्या होगा? तो देखिएगा यहां पर A का कोड लेंथ क्या है? 1003 है. A का 3 है, सॉरी, A का 3 है. सो 3 into 1 प्लस नेक्स्ट देखिएगा B is having 2 B. सो 2 into B का कोड लेंथ क्या है? B का कोड लेंथ क्या है? 2 है. तो 2 into 2 प्लस C भी 2 है. सो C का कोड लेंथ है 2. D कितने? 2 है. 2 into its code length 1 2 3 3. E के 3 है कैरेक्टर्स. 3 into its code length है 2. तो बॉयज एंड गर्ल्स दिस इज माय आंसर. दिस इज माय आंसर. ओके, आई होप यू अंडरस्टूड. तो चलिए नेक्स्ट क्वेश्चन पर जाएं. Shall we go to the next question? Come on, fast. Consider the following statement with respect to a connected undirected graph and tell me the correct answer. Boys and girls, refreshing question है. If G has a unique minimal spanning tree, then all its edges are unique. बोलिए. If G has all unique edges, then it will always has a unique minimum spanning tree. The number of correct statements is or R dash 1 or 2. First statement, is it true or false? First statement, is it true or false? Tulika, Srija Sarkar, Amit Paswan, Anand 21. बोलिए. First statement, is it true or false? Samrat Sachin is saying true. Yash Bedi, I'm asking first statement, is it true or false? come on, first statement, is it true or false? False hai first statement. If I have a unique spanning tree, doesn't mean that all edges should be unique. No, I can have multiple edges with same cost, but I can have a unique spanning tree. Yes or no? I can have multiple edges with same cost, but still I can have unique spanning tree. Boliye. So first statement is false. Second, if G has, हाँ इसका opposite है, if G has all unique edges, दोनों में confusion नहीं होना, G has all unique edges, then there is a unique spanning tree. This is true. I hope you understood. Simple point is, देखिएगा, simple counter example, I don't know why you had a struggle. 2, 2, 3. This graph has got a single spanning tree, unique spanning tree. This graph has got single spanning tree, unique spanning tree, but there are two edges with same cost. I don't know why you had a struggle initially. हाँ, चलिए next. As a homework, you try this simple one. MST से minimum, I mean Prim's algorithm say what is the sequence of edges. I'm very sure you can do it. That's not difficult. Okay. Tell me the answer for this, boys and girls. Tell me the answer for this. Consider the following graph whose minimum cost spanning tree marked with edge values has a weight of 36. Minimum possible sum of all edges of the graph G is dash. Assume that all edges have distinct cost. अगर सारे edges के distinct cost हो तो sum of all the edges क्या होगा? There are 3 edges which doesn't have a cost. There are 3 edges जिसे आप cost assign करना है तो क्या होगा? Using cycle property. Cycle property से आप ये problem solve कर सकते हो. The cost or the weight of this edge, देखिएगा to ये cycle में जो अब तक का हाईएस्ट है 9 है, तो मतलब ये एड्ज आप जो स्पैनिंग ट्री में नहीं आ रहा है तो इसकी वैल्यू 10 होगी, इस वैल्यू होगी 10. जब ये साइकिल बन रही है और इस दोनों स्पैनिंग ट्री में है तो इसकी वैल्यू बनेगी 7. ये जो साइकिल बन रही है इसमें हाईएस्ट अब तक जो है स्पैनिंग ट्री में 15 है तो इसकी वैल्यू होगी 16. तो टोटल वैल्यू बनेगी 69. चलिए नेक्स्ट क्वेश्चन. टेल मी द आंसर फॉर दिस. ये वन ऑफ द लेटेस्ट पेपर का क्वेश्चन है. 1. बोलिए. द नंबर ऑफ डिस्टिंक्ट मिनिमम वेट स्पैनिंग ट्रीज ऑफ द फॉलोइंग ग्राफ इज डैश. कई क्वेश्चंस आए हैं बेस्ड ऑन नंबर ऑफ मिनिमम स्पैनिंग ट्रीज फॉर ए गिवन ग्राफ. कई मेनी क्वेश्चंस लाइक दिस. ये तो गेट आई थिंक 2 years बैक का क्वेश्चन है. 2 years बैक का गेट क्वेश्चन है. So I have a graph with 7 vertices. I need 6 edges. The question is, can I include this edge? हाँ, this edge, yes. ये edge भी रख सकते हो, हाँ रख सकते हो. This one also. ठीक है. These 4 edges can be there. This edge is isolated. ये vertex isolated है अभी. Now I have already added 1, 2, 3, 4 edges. I need 2 more edges because there are 7 vertices. I need 2 more edges. I need 2 more edges. So that may be connecting with this and the other segment. So from these 3 I have to select one. So this can be done in 3C1 into 3C1. 3C1 into 3C1. So ये बनेगा 9. So answer is 9. Okay. Right. Tell me the answer for this. Come on, fast. Alok 6452, yes, as Nishu Kumar is saying, definitely आ जाएगा. Keep the hope. For n equal to 3, this is a complete graph. The weight of this edge is 3, the weight of this edge is 4, the weight of this edge is 5. So the weight of the spanning tree is 3 plus 4. And if I take a graph, if I draw a graph for n equal to 4, if I draw a graph for n equal to 4, तो ऐसे बनेगी ग्राफ. is 1 2 3 4, and I will have an edge from 1 to 3 and 2 to 4. I can't have an edge from 1 to 4. इसका weight होगा 1 plus 2 3, 2 plus 3 5, and this will be 7. 1 plus 3 4, this will be 2 plus 4 6. तो weight of the spanning tree बनेगा 3 plus 4 plus 5 नहीं आएगा, 6 आएगा. So this I can write it like 3 plus 2 into 2 plus 3 for n equal to 4. So based on this I can make a generalization. For a given value of n, the weight of the spanning tree will be 3 plus 2 into 2 plus 3 plus 4 plus so on plus n minus 1. ऐसे आएगा weight of spanning tree. Weight of the spanning tree will come like this. तो इसे आप simplify अगर करोगे, this will be like 3 plus 2 into, this is n into n minus 1 by 2 minus 1. So on simplification, this is nothing but n square minus n plus 1. N square minus n plus 1. The weight of the spanning tree will be n square minus n plus 1. Questions like this are important, boys and girls. That's a simple logical derivation. इसका आंसर बताइए. Generally people confuse with this problem. Generally I've seen people get confused with this problem. Complete undirected graph with 4 vertices. Complete graph. तो और हमने प्रॉपर्टी में ऑलरेडी देखा था, edge with least two, first two least cost, 1 2 will always be. The edge weights are like this. These can be anywhere. So my minimum spanning tree will always have 3 edges here for a graph with 4 vertices. So 1 and 2 will always be part of my spanning tree. 3 may or may not be there. 3 may or may not be there. And पूछा है maximum possible weight. He's asking maximum possible weight that a minimum spanning tree can have. Maximum possible weight that a minimum spanning tree can have. So minimum weight आ सकता है 6. But maximum आने के लिए you should ignore 3 and include 4. That happens when 3 form a cycle. 3 form a cycle. इस तरीके से. So 4 will become the part. So maximum weight will be 7. Maximum weight will be 7. That's a simple one and interesting question. ये भी Huffman coding as a practice you try as homework practice. Huffman coding का question है. ठीक है? You can do it. This is also based on optimal merge pattern. You can do as homework as well. इसका आंसर बताइएगा प्लीज. ये सिंगल सोर्स शॉर्टेस्ट पाथ का एल्गोरिथम है बेस्ड ऑन रिलैक्सेशन प्रोसेस. Based on relaxation process, ये question है PYQ. See whether you can answer. Srija Sarkar, Nishu Kumar, Tulika, please tell what is the answer for this based on relaxation process. Yes, what is the answer? Less than or equal to? Which of the following statements is always true? Boys and girls, which of the following statement is always true? It is said that from the source S, there are two vertices U and V. There are two vertices U and V. Check. It is reported by Dijkstra's algorithm, the cost of the path from S to U is 53 and this is 65. This is 65. So if I have an edge from U to V, agar U to V mein agar edge ho, if we have an edge, then what may be the cost of the edge? What may be the cost of the edge? Can it be less than, boys and girls? Can it be less than 12? क्या less than 12 हो सकता है? Difference कितना है? 12 है. Can it be less than 12? No, it cannot be less than 12. Can it be equal to 12? हाँ sir, it can be equal to 12. But can it be greater than 12? Yes, it can be greater than 12. Are you getting? Hriday, Hridays. It can be greater than 12, yes. It can be equal to 12, but it cannot be less than 12. It cannot be less than 12. So therefore, it has to be either greater than or equal to. D is correct. D is correct. Srija Sarkar is given correct answer. Tulika also gave the correct. So greater than or equal to is correct. चलिए, इसका आंसर बताइए. Reasoning questions like this are important, boys and girls. Reasoning questions like this are important. Let G be a weighted, connected, undirected graph with distinct positive weightage. If every edge weight is increased by the same value, same constant. अगर हर एक edge का same value से आप constant से increase करो, which of the following statements is all true? Minimum spanning tree of the graph does not change, correct? Shortest path is not correct. Shortest path between any pair of vertices change. Shortest path change हो सकता है, spanning tree change नहीं होगा. Spanning tree का structure change नहीं होगा. Spanning tree का cost change होगा. So first is true, second is false. मैचिंग पेयर है, एक बार मैच कर लीजिएगा प्लीज. इवन दो डायनेमिक प्रोग्रामिंग अभी हमने देखा नहीं है, लेकिन स्टिल यू कैन मैच. Kruskal will be mapped to greedy. Quicksort is divide and conquer. Floyd-Warshall is dynamic programming. Direct question है, very simple. So I just wanted to, by means of this question, I just wanted to say कि इस तरीके के मैचिंग पेयर में भी आप थोड़ा केयरफुल रहिए, अपनी नॉलेज बना लीजिएगा, एक बार अच्छे तरीके से पढ़ लीजिएगा. Yes, shortest path can change. SKURD, I don't understand why you are in the class. Why are you in this class? I don't understand. When a person doesn't have any respect for any teacher, then what is the sense in attending the class? आप अपनी तकदीर तो खराब कर रहे हो, so why? What is the meaning in attending the class? When all teachers are nonsense according to you, SKURD SVD of LAML. Nishu, am I right? No, I don't understand. भाई अगर आपको एक टीचर की टीचिंग सही नहीं लग रही है, अच्छा नहीं पढ़ा रहे कह रहे हो आप, नॉनसेंस है कह रहे हो, then what is the fun in attending the class? Why have you come to the class? And I don't understand. जो भी स्पैमर हो, ह्यूमन तो है ना. कुलदीप वर्मा, सिरजा सरकार, कहना यह है कि भाई स्पैमर होगा ठीक है, लेकिन ह्यूमन बीइंग तो है ना, एनिमल तो नहीं है. सो स्टूडेंट भी होगा, हो सकता है, ही मे नॉट बी ए स्टूडेंट. स्टूडेंट तो होगा किसी का, एंड बीइंग ए स्टूडेंट शुड हैव बेसिक मोरालिटी, बेसिक रेस्पेक्ट. इज इट नॉट? नहीं, बात ग्रेटनेस की हस्की नहीं है. बात यह है कि भाई आपका जो ग्रोन अप है, आपकी जो परवरिश है, दैट रिफ्लेक्ट्स बेसिकली. It reflects that. That's what I would say. चलिए, that's why when he commented I didn't respond, I thought he might have left, लेकिन अभी फिर आए हैं साहिब, तो I was surprised, taken aback. चलिए बच्चों, एक ये क्वेश्चन का बताइए प्लीज. इसका आंसर बताइए. Yes, that's correct. Every teacher should be respected. टीचर, इंडिविजुअल की बात नहीं कर रहा हूं, टीचर शुड बी रेस्पेक्टेड, whoever is a teacher. हाँ, ये इट इज ऑफ कोर्स टू लीव, पढ़ाना वो कहना नहीं है, लेकिन फिर भी एक मोरल मेरी रिस्पॉन्सिबिलिटी एज ए टीचर टू रिमाइंड हिम कि टीचर को बुरा भला कहने से टीचर का कोई खराबा होने वाला नहीं है. आप अपनी तकदीर, अपना जो मुकद्दर है आप वो खराब कर रहे हो, ये कहना चाह रहा हूं मैं. वो भी तकलीफ दे बात है हमारे लिए. कोई स्टूडेंट अपना तकदीर, अपना मुकद्दर, अपना फेट अगर खराब कर रहा है, वो भी हमें तकलीफ होगी, ये मैं कहना चाह रहा हूं. चलिए बच्चों, बेलमैनफोर्ड एल्गोरिथम. बेलमैनफोर्ड एल्गोरिथम इज ऑर्डर ऑफ n into m. प्लीज रिमेंबर, ऑर्डर ऑफ n into m. क्रस्कल एल्गोरिथम ऑर्डर ऑफ m log n हो सकता है. फ्लॉयड-वार्शल्स एल्गोरिथम ऑर्डर ऑफ n cube. And topological sort, as we shall see in depth first search, order of n plus m. These are correct matching. ये correct matching है. ठीक है? So this is about some of the basic questions with regard to greedy method. So boys and girls, okay, whatever ABCD you can match, that is the correct matching. ठीक है? A is correct, 1 is C, and 2 is A. Yes, 3 is B, and 4 is D. That's right. So boys and girls, greedy method almost done, and we have now to begin our discussion with dynamic programming, one of the basic and important, one of the basic important design strategy. Nishu Kumar, I am thinking like I will just give a basic introduction to dynamic programming, basic introduction. उसके बाद हम डिनर का ब्रेक के लिए जाएंगे 15-20 minutes, then I will continue. Is it okay? Just 10 minutes we'll have a basic introduction so that we can have continuity. Okay. So boys and girls, one of the important technique of algorithms design strategy वो है dynamic programming. Dynamic programming, popularly written in short. Okay, Dashrath, you are in Ace College, very good. So this is popularly written in short by an industry. We generally use the word as a buzzword called DP, dynamic programming. Essentially it's a method for solving complex problem by breaking into smaller problems. आप कहोगे जैसे divide and conquer, हाँ बिल्कुल. There is a similarity between divide and conquer and dynamic programming. In respect that we break up the problem into smaller and easier sub problems. लेकिन कुछ differences है between divide and conquer and dynamic programming, मैं आपको highlight करूँगा. But before that, some historical relevance. Relevance ये है कि this term dynamic programming was coined by a mathematician and a researcher by name Richard Bellman. Bellman-Ford algorithm जो है Bellman, that is what is the concept, Richard Bellman. Early in 1950s, when he was working in a company by name Rand Corporation, okay, he developed this technique by name dynamic programming. This is the person, and he said he thought that dynamic programming was a good name because it was something not even a congressman, means US के जो politicians a congressman could object to, so therefore he used it for his research, umbrella of research under this programming. कहना यह है कि programming does not refer to coding here. First point, the word programming is not coding here. Please remember that the word programming is not coding. Please understand. The programming जो word है, that is basically a method for tabulating the results of sub problems which are to be retained, which are to be stored or cached. ये है concept of programming. ठीक है? So again I would say, please understand, dynamic programming like greedy method, boys and girls, dynamic programming like greedy method is also a design strategy used for solving problems whose solutions are seen as a result of making a sequence of decisions. So this statement जो मैं कह रहा हूं is also applicable to dynamic programming जो greedy method में था. This was applicable in greedy method also. Any problem that needs to make a sequence of decisions, a set of decisions, We can solve using dynamic programming and also greedy method. फिर उसके बाद क्या कहता है देखिएगा, author says one way of solving or making these decisions is making the decisions in a stepwise manner, step by step, based on local optimality principle, based on local optimal options, local options, greedy about local options, greedy with respect to local options. One way of solving such problem that needs to make a sequence of decisions is to make the decisions in a step-by-step manner based on local optimality. This is true of problem solvable by greedy method. This is true. ये statement true है for greedy problems. So one way of making these decisions is to make them one at a time in a step-by-step manner and never make an erroneous decision. This is true for all problems solvable by greedy method. ये approach correct है for greedy strategy. लेकिन परंतु but there are many other problems for which optimal sequence of decisions cannot be made by making the decisions in a stepwise manner. There are many problems for which decisions, optimality cannot be achieved by making stepwise decisions in stepwise manner or step by step in such a manner that the sequence lead to optimality. Like for example, sir कौन से problems है? There are many problems. Example कह रहा हूं. One of the problem for which optimality cannot be achieved by making the decision in a stepwise manner is a problem called multi-stage graph. ये problem का नाम है multi-stage graph, boys and girls. Multi-stage graph, where I have the vertices of the graph placed in stages. Stage 1, stage 2, stage 3, stage 4, stage 5. First and last stage will have a single vertex, boys and girls. First and last stage will have a single vertex. And the other vertices are divided in the remaining stages, like stage 2 has 4 vertices, 3 vertices, 3 vertices. Generally, this graph is a directed graph, weighted graph, positive weightages. और ये ग्राफ के जो प्रॉब्लम्स है मल्टी स्टेज ग्राफ के, वी फाइंड ए नंबर ऑफ प्रॉब्लम्स इन सिविल एंड मैकेनिकल इंजीनियरिंग बेस्ड ऑन फ्लो स्ट्रक्चर. So it's a realistic problem. So boys and girls, the problem is to find the shortest path from the vertex S, which is 1, to vertex T, which is destination 12. From the first stage vertex to the last stage vertex हमें shortest path determine करना है. ठीक है. तो my question is, can we solve this problem using greedy method? और अगर हम greedy method से solve करने की कोशिश करेंगे, तो what is the solution that are we going to get for this instance? So let us see. Boys and girls, please report to me. अगर आप ये problem को greedy method से solve करोगे, you know by this time what is the greedy approach. Tell me what is the cost of the path that will be reported. Tulika, Nishu Kumar, please tell. Yash Bedi, Kamlesh Kumar, please tell. If I try to work out the solution to this using greedy approach, what is the cost of the path that will be reported by greedy method? Cost of the path बताइए. Greedy method say that at step 1, what are the options? Options are 9, 7, 3, 2. So it will go to 5. So from 1 it will go to 5. 5 पे आने के बाद I have two options, 8 and 11. So naturally it will go to 8. From 8 it has two options, 5 and 6. It will go to 10. Vertex 10. And from 10 it will go to 12. So boys and girls, this is a path reported by greedy method. Greedy कहेगा कि भैया मुझे ये path दिख रहा है with a cost value of 17. With a cost value of 17. I get the solution. मुझे path तो मिला है लेकिन गलत पाथ है. Cost is 17. Question is, does there exist an alternate path in the graph which has a cost value more than 17, less than 17? Like if you observe this path 1, 2, 7, 10, 12. This is also a path. I don't know how we found, but this is also a path. And if you observe, the cost of this path is 16, means less than what is obtained by greedy. तो इसका मतलब ये है, साफ मतलब ये है कि this problem of multi-stage graph cannot be solved using greedy method. This problem of multi-stage graph cannot be solved using greedy method. We cannot get optimal solution of this using greedy strategy. Greedy method fails. Why has greedy method failed? Listen to me. Why has greedy method failed? Greedy method selected this path at the first step without bothering whether the resulting sequence of decisions will they be optimal or not. Greedy method does not bother. The resulting 1, 2 is highest cost, but the resulting cost of the path from 2 to 12 is having lesser value than 1 to 5 and 5 to remaining 12. So greedy method only talk about local optimality. Greedy method does not talk about greedy or local optimality. Nirvana, you can apply greedy method from back also, there is no issue. Sometimes it may work, sometimes it may not. Are you getting my point? Even you apply Dijkstra's algorithm, it will work. But pure greedy for this does not work. Dijkstra's algorithm is not single pair shortest path, is single pair shortest path. Please understand. So greedy method is based on local optimality principle, which never talks about the consequence of the first decision. So we require a strategy which is not only going to consider the current local optimality, but the consequences of it. What is the impact of the decision which is being made at the current state? The resulting cost of the path from the first decision, will it be optimal or not? We have to see, and that is what is the focus of dynamic programming. So boys and girls, like multi-stage graph, we have other problems. We have 0-1 knapsack, you can try, it won't work with greedy method. We have coin change problem, won't work with greedy method. Traveling salesperson doesn't work always with greedy method. There are like that innumerable problems which does not give optimal solution with greedy strategy. So for solving such problems, one approach is using brute force, boys and girls. One way of solving such problem for which optimal sequence of decisions cannot be arrived by applying stepwise decisions is to go for brute force. आप क्या करना है? Brute force से करना. अगर आप brute force से जाओगे, solution आएगा optimal solution, लेकिन क्या होगा? Time and space complexity will become enormous. Brute force से time and space complexity will become enormous. Exponential time होगा most of the time. So dynamic programming based on, listen to me, dynamic programming का जो evolution है, it is based on enumeration, लेकिन it will apply some optimizations. It will apply some optimizations, like tabulating the results of the sub problems and storing them to reuse them rather than recompute and optimize the time. And it will cut off some decision sequences which will optimize the time, and therefore it will try to reduce the complexity from exponential, right, exponential to polynomial in most of the cases. So that is the basic notion, basic ideology of dynamic programming. So dynamic programming based on enumeration, it will make the decision by applying principle of global optimality. Principle of global optimality. क्या है principle of global optimality? देखिएगा. Principle of optimality, global optimality states that this is the working principle of dynamic programming. It states that whatever the initial state, listen, whatever the initial state and decision are, global optimality principle dynamic programming की क्या कहती है? Whatever the initial state and decision are, the remaining sequence of decisions must constitute an optimal decision sequence with regard to the first decision. With respect to the first decision, the remaining sequence of decision भी optimal होना चाहिए. ये कहता है principle of global optimality, जो कॉर्मन की टेक्स्ट बुक में optimal substructure property है. So global optimality principle is not applicable in greedy method. That's why it fails. And why dynamic programming is successful? Because it is based on global optimality principle, optimal substructure, and therefore it always gives you optimal solutions because it is based on enumeration. ये है fundamentally. So this is the essential aspect of dynamic programming. There are two ways of solving the problem based on dynamic programming. एक approach है top down, दूसरा है bottom up. ये हमें understand करना पड़ेगा. Top down approach is also called memoization approach. वो क्या है memoization? And then bottom up approach, tabulation method क्या है? We will try to understand it by taking a suitable example. Our example है well known problem है Fibonacci number. Computing n Fibonacci number, we can demonstrate elements of dynamic programming. Computing n Fibonacci number, we can demonstrate the elements of dynamic programming and the approaches of dynamic programming, and so that we can solve other problems of it. So अब यहाँ पर हम एक break लेंगे, as I said, right, 15 minutes break for a quick snack or dinner. उसके बाद I will take up case study of nth Fibonacci number, computing nth Fibonacci number using pure brute force, divide and conquer, then using memoization approach, using tabulation approach, and then finally we will solve some other problems of dynamic programming, like I will show you a traveling salesperson problem and a 0-1 knapsack problem, matrix chain multiplication, longest common subsequence. इसके formula solution देखेंगे with dynamic programming approach as case studies. ठीक है? So we'll have a small break, 15 minutes. So we'll Meet at 9:15. Is it okay? 9:15, 20 minutes. Yes. We'll meet at 9:15 for a quick break, short break, and continue with dynamic programming after the break. So go for dinner and come back fast. Okay, boys and girls, will start. Back. Audio, video clear? Come on, boys and girls, you just give me the clearance so that we can start. Okay. So, boys and girls, I was talking about, yes, thank you. I was talking about the dynamic programming and the basic ideology of it. So, essentially based on enumeration, but often tries to reduce the complexity from exponential to polynomial in most of the cases, by either using the rule of memoization, caching the results of the subproblems, or basically cutting down the decision sequences and thereby bringing down the complexity. So to illustrate this philosophy and also explain, आपको elements of dynamic programming explain करने के लिए एक case study हम लेंगे जो very good example है computing the nth Fibonacci number. Look at this. Computing the nth Fibonacci sequence. I hope for those who don't know Fibonacci sequence, I'm very sure everybody knows these are Fibonacci numbers. Some of the previous two numbers is Fibonacci sequence. So this is the order. Is it not? So if I try to write a recursive algorithm for computing nth Fibonacci number, तो algorithm कैसे दिखेगा? सभी को पता है, सभी ने प्रोग्रामिंग और डेटा स्ट्रक्चर्स में जरूर पढ़ा होगा. Computing the nth Fibonacci number, the typical recursive equation, mathematical recurrence is this: fib of n is equal to fib of n minus 1 plus n minus 2, sum of the previous two numbers when n is greater than 1. N is equal to 1, it is 1, and n equal to 0, it is 0. This is the boundary case, the base case, and this is a sequence. So boys and girls, if you try to, अगर आप ये algorithm को implement करो using traditional approach या brute force approach या divide and conquer method से direct अगर आप implement करोगे, then the algorithm would somehow look like this. This is the normal recursive implementation of fib of n. This is without DP, boys and girls. This is without DP, without dynamic programming. ठीक है? So int n, if n is less than or equal to 1, then return n, else return fib of n minus 1 plus fib of n minus 2. तो इसका अगर आप expansion देखोगे for any particular value of n, fib of 5, fib of 7, fib of 11, if you try to expand, you would find that the complexity of this algorithm in the traditional sense में इसकी टाइम कॉम्प्लेक्सिटी अगर आप इवैल्यूएट करोगे तो आपका मैथमेटिकल रिकरेंस वही बनेगा जो मैथमेटिकल इक्वेशन था. इट विल बी लाइक t of n is equal to t of n minus 1 plus t of n minus 2 plus some constant work for returning the result and making the sum of these two. And boys and girls, this will be equal to, as you said, n for n less than or equal to 1. This is the case when n is greater than 1. ये हमारा recurrence है for this. And if you try to solve this recurrence, I'm very sure using recursion tree method से अगर आप इसे solve करोगे, the time complexity of this will come out to be order of 2 power n and omega of 2 power n by 2. It is not theta of 2 power n. ये time complexity. You have to remember this as a lifetime concept. The time complexity using non-dynamic programming approach or simple recursion, recursive, direct recursion, normal recursion is order of 2 power n, omega of 2 power n by 2. This you can solve it by recursion tree method. अब मैं यहाँ पर recursion tree method आपने already बताया था, वो method अगर आप solve करोगे, apply करोगे, you will get this value. So if you see this tree structure for fib of n for this same implementation, if I try to draw the tree for fib of 7, which is value 13, this is my recursion tree. Fib of 7, then 6, then 5, then 4, then 3, 2, 1, and fib of 4 again will compute fib of 2, right? Fib of 3 will be again computed by expanding the whole thing. Fib of 4, which was computed here, will be computed again here. So here, if you observe, boys and girls, if you observe carefully, there are many recomputations happening. The time complexity exponential बन रही है because of recomputations. Fib of 4 पहली बार हमने यहाँ पे कंप्यूट किया, यहाँ पर फिर से कंप्यूट कर रहे हैं. We are expanding this tree again. फिब ऑफ 3 हमने यहां पे कंप्यूट किया, यहां पे भी कंप्यूट किया, यहां पर भी कंप्यूट किया, यहां पर भी, यहां पर भी, यहां पर भी. Because of this expansions again and again and again, time complexity is increasing. More and more number of recursive calls is increasing the time exponentially. क्या ही अच्छा होता बॉयज एंड गर्ल्स, क्या ही अगर अच्छा होता, एक बार जब आपने फिब ऑफ 3 की वैल्यू कंप्यूट की तो वहां पर कहीं आप टेबल में स्टोर कर लेते, so that you can reuse the value rather than recompute. अगर ऐसा हो सकता तो टाइम कॉम्प्लेक्सिटी वुड हैव बीन रिड्यूस्ड. और यही आइडियोलॉजी है डायनामिक प्रोग्रामिंग की, मेमोराइज या टॉप डाउन अप्रोच में. समझ रहे हो? क्या ही अच्छा होता अगर इफ यू कंप्यूट द वैल्यू ऑफ फिब ऑफ 3 once and store it. Like that, fib of 2 also you store it, fib of 4 also you store it. So store the results of the sub problems. ये जो प्रोसीजर है स्टोर करने का रिजल्ट्स ऑफ सब प्रॉब्लम्स को, that is called programming. That is called programming. So programming is not coding. The process of tabulating the results and caching them, that is called programming, dynamic programming. So dynamically problems को divide कर रहे हैं और store कर रहे हैं. That's the coining of the word dynamic programming. So this is the essence of dynamic programming. ठीक है? So it will avoid the computation of the problems again and again, and therefore reduce the complexity. So there are two ways of implementing dynamic programming, and by this we are trying to say that there are two elements of dynamic programming. क्या है दो elements? एक है division of the problem into sub problems. That property is called optimal substructure. That means we are expressing the solution to our problem in terms of sub problem. यहाँ पे देखिएगा sub problem. This is called optimal substructure. The computation of the problem, original problem, is done in terms of sub problems, and you should be having the ability to divide the problem into sub problems. And second most important dynamic programming principle or element is overlapping sub problems. Almost all dynamic programming problems are characterized by overlapping sub problems. जब तक overlapping sub problems ना हो, आप memoization नहीं कर सकते. You cannot memorize. Memoization is only done for overlapping sub problems. Overlapping का मतलब क्या है? Common sub problems. तो ये देखिएगा common sub problems है. Problems are overlapping. This is done first time here, again overlap. So अगर problem में overlapping sub problems हो, तब dynamic programming is useful. Otherwise, if there are no overlapping sub problem, जैसे merge sort है, you are again dividing the problem into sub problem. Merge sort में optimal substructure है, लेकिन overlapping sub problems नहीं है. That's why you cannot optimize the time further in merge sort. समझ रहे हो? Overlapping sub problem will result in the application of the concept of caching or memoization. समझ रहे हो? So there are two important elements: optimal substructure property and overlapping sub problems. So any problem which exhibits optimal substructure and overlapping sub problem can be solved using dynamic programming, either through memoization approach or through tabulation approach. तो सर memoization approach से कैसे solve करोगे और tabulation approach से कैसे solve करोगे, तो देखेंगे यहां पर. सुनिएगा. This is the memoized implementation of Fibonacci, computing the nth Fibonacci number. I would appreciate, please have a look at this code carefully, everyone. Please have a look at the code carefully for understanding this memoized implementation of computing nth Fibonacci number. This is also called top-down approach. तो यहां पर हम एक टेबल लेंगे. Listen to me. The table name is M, an array basically. So if I compute this M, if I compute M fib of 5, so I will have 0, 1, 2, 3, 4 and one more element 5. Initially all elements are undefined. I will put dash undefined. I don't know M of 0, M of 1, M of 2, and these are undefined values. Initially I don't know anything. So if I don't know anything, I keep on working recursively to find the solution to the problem. So look at this definition. If M of initially n is 5, M of 5 is undefined, n is less than or equal to 1, no. Else I come here, I make a call fib of n minus 1, then fib of n minus 2. So first I make a recursive call. तो मतलब अगर fib of 5 आप compute कर रहे हो, if you are computing fib of 5, so it will make a recursive call to fib of 4. It will make a recursive call to fib of 3. It will make a recursive call to fib of 2. It will make a recursive call to fib of 1. जब fib of 1 में आओगे, m of 1 is also undefined. I enter here. N is less than or equal to 1. Yes, n is equal to 1. Result is equal to n. So in m of n, we will show the result. That means m of 1 will write 1. First time we will write here. First time we'll write here. M of 1. 1. First time we are writing. So that next time if I call m of 1, I will directly use the result from here. That is the basic ideology. फिर उसके बाद fib of 2 में you will make a call to fib of 0. Fib of 0. Fib of 0 will also store the value 0 here and return the result. So this will return 0, this will return 1. 1 plus 0 will become 1. So you store fib of 2, the value 1. 0 plus 1 will store 1 here. फिर उसके बाद क्या होगा? Now fib of 1 is computed, 0 is computed, 2 is computed. For every unique call we have made one function call. इसके बाद आप return करोगे value 1 here. Fib of 3 in the call will make a call to fib of 1. But fib of 1 is already defined. I don't work out, I don't expand. Fib of 2, fib of 1 is already worked out. So therefore directly it will return without computation the value 1. तो ये क्या होगा? 1 plus 1, 2 value, 2. Fib of 3 में आप 2 store करोगे. M of 3 में 2 store करोगे, so that in future में अगर आप जरूरत पड़े तो directly use the value. So 1 plus 1, sorry, fib of 3 has computed 2. 2 is returned to this point. 2. So fib of 4 will now, boys and girls, please observe, will make a call to fib of 2. क्या fib of 2 is already defined? हाँ sir, 2 is already defined. समझ रहे हो? And this will return, fib of 3 will return 1 here. ठीक है? Result is stored as 2 and this will return. So fib of 2, what will it return? Sorry, 2, 1 plus 1, 2, and this will return 1. So 2 plus 1, 3 is computed and 3 is stored here. 3 is stored here. And this will return 3. Then fib of 5 will make a call to fib of 3. Look at that, we are not expanding this, we are not expanding this. Fib of 3, finally value is known 2, yes. So it will directly return 2 here. 3 plus 2, 5 is stored in fib of 5, 5 is stored and it will return 5. So the answer is 5. So boys and girls, we have not expanded this. This has been done. These computations have been done in order of 1 time. Order of 1, order of 1, order of 1. So that means the recursion has proceeded for depth fib of 5 to fib of 1. That means n recursive calls. So time complexity kya bani? Time complexity of this algorithm is order of n. Time complexity is order of 1, order of n. So we have reduced the complexity from order of 2 power n. यहाँ पर 2 power n था. We have reduced it from order of 2 power n to order of n. ये memoized implementation. Top down implementation है. Top down implementation, memoized implementation generally is done with recursion. Bottom up implementation is done iteratively. Tabulation approach is done iteratively. ये देखिएगा, ये है bottom up approach of dynamic programming for computing nth Fibonacci number. Here also we have a table, but this computation is done bottom wise. So I just need a loop. This direct implementation. M of I is equal to M of I minus 1 plus M of I minus 2. This is an array. इसकी भी time complexity आप देखोगे directly order of n. So therefore, we dynamic programming implementation either top down or bottom up for recursive for computing n Fibonacci number order of n rather than order of 2 power n. So that is the beauty of dynamic programming. So boys and girls, the point to be remembered, number 1. Problems can be solved. Optimization problems, decision problems can be solved in a stepwise manner, greedy approach. Not in a stepwise manner by applying global principle of optimality, provided problems has optimal substructure and overlapping subproblems you can solve using dynamic programming, either by top-down approach or bottom-up approach, either through memoization or through tabulation approach. लेकिन ये solve करने के लिए you need to have the formula. जैसे फिबोनाची का आपने formula derive किया, उसी तरह हर प्रॉब्लम का फॉर्मूला डिराइव करना होगा एंड देन बेस्ड ऑन दैट यू विल हैव टू इंप्लीमेंट दैट फॉर्मूला आइदर इन रिकर्सिव मोड और नॉन रिकर्सिव मोड, बॉटम अप और टॉप डाउन. सो आई विल शो यू. सो इन द एग्जाम्स क्वेश्चंस जो डायनामिक प्रोग्रामिंग के पिछले PYQs में जो आए हैं वो आए हैं बेस्ड ऑन फॉर्मूलेस, बेस्ड ऑन न्यूमेरिकल कंप्यूटेशंस. आई विल शो यू बोथ फॉर सम ऑफ द प्रॉब्लम्स. तो केस स्टडीज लेंगे, सम ऑफ द केस स्टडीज अपार्ट फ्रॉम दिस. The first problem I would like to work out is traveling salesperson. You know very well what is traveling salesman. There is a traveling salesperson who is supposed to organize a tour by visiting n cities. One of the cities is the home city. So home city से start करेगा, we should visit the remaining cities exactly once and come back to the home city. ये है traveling salesperson. With an intention objective to minimize the cost of the tour. अगर ये प्रॉब्लम को आप फॉर एग्जाम्पल इफ आई हैव द टूर, इफ आई हैव द सिटी रिप्रेजेंटेड बाय अ ग्राफ, द सिटी नेटवर्क इज रिप्रेजेंटेड बाय अ ग्राफ एंड लेट्स से देयर आर n cities, n vertices. Let's say there are n cities or n vertices. Generally the graph is a almost like complete graph, fully connected graph. Then only it is meaningful. तो आप बताइएगा, let me see who will answer. What is, and one of the city is designated as source. V0 is called source. Vertex 1 या 2 या 3 या 4 या 5 कोई भी vertex को आप source की तरह use कर सकते हो. So my question is, let me see who will answer. What is the size of solution space? मैं बार बार कह रहा हूं, दोहरा रहा हूं. Based on my experience, you can expect a question sometime in the GATE exam on size of solution space. Size of solution space of greedy and dynamic programming problems. Please remember, try to understand and try to remember what are the sizes of solution space of the problems. So all the previous problems के हमने size of solution space determine किए. क्या आप बता सकते हो what is the size of solution space of traveling salesperson? n-1 factorial. That's correct. क्योंकि one of the city is designated as source city. So source cannot be visited again, cannot come in the in between. So from 1, for example, if you select source as 1, you have to select the remaining n-1 cities with permutations. So n-1 factorial. n-1 factorial. So condition is that every city should be visited once. So boys and girls, for example, if I can think of solving this problem using dynamic programming, if I can think like this is my problem. I'm having n equal to 4 vertices, n equal to 4 cities. Let us say any city is designated as source. I take V0 is equal to 1. This is my cost adjacency matrix C. This is my cost adjacency matrix C. ठीक है? तो if I solve this problem using greedy method, please observe. अगर हम ये problem को greedy method से solve करेंगे, तो क्या solution बनेगा? What is the solution that we are going to get? What is the size of solution that, what is the solution that we are going to get when we solve this problem using greedy strategy? Using greedy strategy. So when I start from vertex 1, boys and girls, please tell me. When I start from vertex 1, using greedy method, देखिएगा cost from 1 to 2 is there, 1 to 3 is there, 1 to 4 is there. So where will I go? 1 to 2 या 3 या 4? 1 to 2 is the least. So greedy will go for 2. And from 2 if I start from 2 now, if I start this 1, this is 2. So options are what? 2 to 3, 2 to 4. So 2 to 3 is less, so I will go to 3. And from 3 I have no option other than going to 4 and come back to 1. This is what is reported by greedy method. This is what is reported by greedy method for this data set. अगर आप इसका cost determine करो, the cost of this tour as reported by greedy method, this is having cost value 39. Check it. The cost value है 39. Is it not? लेकिन if you observe another path, another tour, 1, 2, 4, 3, 1. What is the cost of this tour, boys and girls? ये भी एक tour है. I don't know how we got, but this is also a tour. Can anybody tell me what is the cost of this tour? Can anybody tell me what is the cost of this tour? 1, 2, 4, 3, 1. The cost of this tour, if you try to see from the graph, it is 35. So this again proves that greedy method has failed for solving this problem. Greedy method has failed for solving this problem. Why has greedy method failed? क्यों fail हुआ? Reason is same. No problem, we are going from 1 to 2 in both. लेकिन greedy has greedily opted to go for 3 without bothering whether the resulting cost of the tour from 3 to 1 will be optimal or not. Greedy method does not bother. लेकिन 2 to 4 higher cost है, but the overall cost from 4 to 1 is having lesser value. That's why greedy has failed and dynamic programming has succeeded. So therefore this means principle of optimality applies. Whatever my initial state and decision are, the remaining sequence of decisions are considered here. So therefore optimal substructure, optimal principle apply. अब अगर tree structure generate करोगे तो it will exhibit overlapping subproblems also, and hence this problem can also be solved using dynamic programming. तो डायनेमिक प्रोग्रामिंग से सॉल्व करने के लिए आपने रिकरेंस बनाना होगा, रिकरेंस रिलेशन, रिकर्सिव इक्वेशन, so that you can implement it using memoization or using tabulation, either way. So how do you formulate the recurrence? It's very simple based on principle of optimality, optimal substructure. Please see here. I assume that this is the cost adjacency matrix C. Cij represent the cost of the edge. Cij represent the cost of the edge. और हमें path cost चाहिए, tour cost चाहिए. So for that we'll assume some variable. We'll assume it like this. Let GIS represent cost of the tour. GIS represent the cost of the tour from vertex I which is the source, for example, and visiting the vertices in the set S. S is a set of vertices in the set S. How? Exactly once, and terminate at V0. What is V0? V0 is the source. Cost of the tour from vertex I, visiting all the vertices in the set S exactly once and terminating at source vertex V0. तो इसका फॉर्मुलेशन कैसे होगा? For our graph, the initial values of I and S are 1, 2, 3, 4. Suppose if source is V0 is equal to 1, अगर मैं V0 को 1 लूंगा तो मेरा ये कंप्यूटेशन इनिशियल कंप्यूटेशन होगा. So how do you derive this? We want to minimize the cost of the tour. मैं minimization function apply करूंगा. The derivation on the right hand side will be purely based on optimal substructure property. कैसे? Please see here. So from vertex 1, I must visit some vertex k. From 1, I should visit some vertex k where k belong to S. S may be 2, 3, 4. And there should be an edge from here 1 to k. The cost of the edge is given by C1k. You visit that k, maybe 2 or 3 or 4. So 1 and k is an edge, such that the remaining cost of the tour from k to V0, k to 1 is minimum. ये है remaining cost of the tour. तो ये remaining cost of the tour आप कैसे express करोगे in terms of the same function, substructure? कैसे express करोगे? So C of 1 comma k plus g. Now the tour is commencing from k. What are the vertices remaining to be visited? S minus k. ये है equation. So here I will say k belong to S and 1 comma k belong to E, set of edges. ये है g of 1 comma 2, 3, 4, C of 1 k plus g of k comma S minus k. समझ रहे हो? This is the point. So how do you generalize this? How do you generalize this for any value of I and S? So the generalization of this will become like this: minimum of C of I should go to some vertex k where k belong to S and there must be an edge from I to k, plus g of k comma S minus k. This will remain as it is, g of k comma S minus k, like this. So look at that, just like our Fibonacci formula, this is a formula for traveling salesperson. This is a formula for traveling salesperson. The value of G is computed again in terms of G, just like the value of fib is computed in terms of fib. This is the optimal substructure. Optimal मतलब minimization, substructure, sub problem. अगर आप इसका ट्री स्ट्रक्चर बनाओगे, मैं नहीं, टाइम नहीं है, नहीं बना रहा हूं, आप बना के खुद से देखिएगा, you will have overlapping sub problems. So it exhibits optimal substructure property and satisfy overlapping sub problems. So you can easily convert this formula into a memoized algorithm, recursive algorithm, or maybe a tabulation approach. ये है basically traveling salesperson. इसका boundary condition base case बना सकते हो. The base condition will work like this: g of I comma phi is equal to C of I comma V0. ये base condition बनेगा. So it can become a full-fledged answer. So my dear students, boys and girls, please understand. This is one type of question which were asked in earlier paper of GATE. For a given problem, they will ask you what is the formula, options A, B, C, D. You have to select the correct option. ये आप सभी कर पाओगे जब आपको अंडरस्टैंडिंग हो डायनेमिक प्रोग्रामिंग के प्रिंसिपल्स की. You know what is substructure, you know what is overlapping sub problem, तभी आप करेक्ट ऑप्शन सेलेक्ट कर पाओगे. So my request, at least minimum आपने क्या करना है? Minimum आपने ये करना है कि for every standard problem, you try to conceptually remember, not remember by heart, conceptually remember the recurrences of important problems. जैसे कि traveling salesperson, Floyd-Warshall's algorithm, 0-1 knapsack, sum of subsets, optimal binary search tree, longest common subsequence, ठीक है, मैट्रिक्स चेन प्रोडक्ट, ये सभी स्टैंडर्ड प्रॉब्लम्स के रिकरेंसेस जैसे ये रिकरेंस है, रिकरेंसेस यू रिमेंबर कॉन्सेप्चुअली, जैसे मैंने यहां पर डिराइव किया, ये कॉन्सेप्चुअल डेरिवेशन है, रिमेंबरिंग मैंने याद नहीं किया, ये उसी तरह आपने भी याद करना, आपने भी रिमेंबर करना है, कॉन्सेप्चुअल रिमेंबरेंस. दैट इज व्हाट इज एक्सपेक्टेड. इसके बाद इसका सोल्यूशन है, इसका उसका सोल्यूशन है। सोल्यूशन कैसे निकालेंगे मैं प्रैक्टिस क्वेश्चन में बताऊंगा। तो ये एक प्रॉब्लम है बच्चों, इस तरीके से करना है। उसी तरह अगर आप फ्लॉयड वार्शल्स एल्गोरिथम है, ऑल पे शॉर्टेस्ट पाथ, इसका भी अगर आप रिकर्सिव फॉर्मूला डिराइव करना चाहो कर सकते हो। व्हाट इज द रिकर्सिव फॉर्मूला? ऑल पे शॉर्टेस्ट पाथ्स, ठीक है। उसका भी मैं आपको सोल्यूशन बताऊंगा, देखिएगा। और एक भी केस स्टडी कराऊंगा 0-1 नैपसैक का, सो दैट यू गेट सम आइडिया इन दिस रिवीजन सीरीज। सो ऑल पे शॉर्टेस्ट पाथ फ्लॉयड वार्शल्स एल्गोरिथम is basically for solving the problem of shortest path for all pair of vertices. This is a problem which is solvable by both Dijkstra and this greedy and this. Greedy से भी वर्क कर सकते हो, डायनेमिक प्रोग्रामिंग से भी वर्क कर सकते हो। तो कैसे डिराइव करेंगे फॉर्मूला? लेट्स टेक अप। बॉयज एंड गर्ल्स, ये इतना इंपॉर्टेंट प्रॉब्लम है कि दिस वाज आस्क्ड इन फैंगमैन कंपनी इंटरव्यूज मेनी टाइम्स। गूगल, फेसबुक, दैट इज मेटा, एंड माइक्रोसॉफ्ट, सेल्सफोर्स, अमेजॉन, कई लेवल 1 प्रोडक्ट बेस्ड कंपनीज में इसके ऊपर क्वेश्चंस आए हैं। सो देयरफॉर दिस इज ए सुपर वाइटल वेरी इंपॉर्टेंट प्रॉब्लम। सो बॉयज एंड गर्ल्स, दिस इज माय ग्राफ फॉर विच आई वांट टू फाइंड द शॉर्टेस्ट पाथ। सो उसके लिए मुझे डेरिवेशन करना है। सो लाइक अर्लियर ओकेजन आई इमेजिन दैट द ग्राफ इज रिप्रेजेंटेड बाय कॉस्ट एडजेसेंसी मैट्रिक्स C. Cij represent the cost of the shortest path, cost of the path, sorry, Cij represent the edge cost, और हमें path cost चाहिए. So we'll imagine a notation, a variable, a function a power kij represent cost of the path from vertex I is the source to vertex j is the destination. A power kij represent the cost of the path from vertex I to vertex j, with k being the highest intermediate vertex. K being the highest intermediate vertex. देखिए, between two vertices I can have a path, और वो path के बीच में कुछ vertices हो सकते हैं, and we are numbering the vertices of the graph as 1 to n, 1 to n. एक ग्राफ है जिसमें n vertices है, sequentially numbered from 1 to n. So for any vertex I as source and j as destination, the highest intermediate vertex जो आ सकती है between I and j is n, is it not? एक ग्राफ है, जैसे कि if I take this graph with 3 vertices, if I say the path from 1 to 2 may be a direct path, direct edge, या फिर I can have a path for example like 1, 3 then 2. Of course यहाँ पर 3 to 2 नहीं है, लेकिन ऐसा हो सकता है. Imagine I have an edge like this. So I can have an intermediate vertex of 3. I can have an intermediate vertex of 3. So कहना यह है कि between two vertices I and j, the highest intermediate vertex that could lie between I and j, is n. लेकिन shortest path may go through n, may not go through n. क्या ये जरूरी है कि shortest path should go through highest intermediate vertex? No, it may or may not. तो यही बेसिस पर हम डिराइव करेंगे इक्वेशन, shortest path going through k, shortest path not going through k. तो k represent the highest intermediate vertex, and the highest value of k is n because the graph has n vertices. तो कैसे होगा derivation? Boys and girls, I want your attention. Please follow. These are very interesting derivations. A power kij. I want to minimize the cost of the path. Minimum of what? 2 possibilities. क्या है 2 possibilities? Okay, Anand 21. Very good. Amazon में SD के लिए है कोडिंग आपका, वेरी गुड. सो आई होप डायनेमिक प्रोग्रामिंग आपकी अच्छी स्ट्रांग होगी. आनंद 21, आई बिलीव यू आर गुड इन डायनेमिक प्रोग्रामिंग कोडिंग. सो ए पावर के आई वांट टू मिनिमाइजेशन ऑफ 2 possibilities. Shortest path going through k, shortest path not going through k. So a power kij logically represent like the shortest or the path from I to j with k being highest intermediate vertex. ये मतलब है. This is a power kij, k being highest intermediate vertex. So shortest path may go through k, may not go through k. अगर if it is not going through k, the next highest intermediate vertex is k minus 1. अगर k से नहीं जा रहा है highest intermediate vertex, तो क्या होगा next? k minus 1. So it will be like a power k minus 1 not going through k. Or if it goes through k, अगर वो k से जा रहा है, then I apply optimal substructure, boys and girls. If it is going through k, I can break up my path from I to j into 2 subpaths. What are the two subpaths? One is from I to K, the other is from K to J. One is from I to K, the other is from K to J, two subpaths. Now my I is source, K is destination, K is source, J is destination, two subpaths. And logically, mathematically, the shortest, the path from I to K will have highest intermediate vertex K minus 1, K minus 1, next highest value. K is the highest, so next higher value after K, K minus 1. तो इसको आप रिकर्सिवली कैसे लिखोगे? इसको आप ऐसे लिखोगे, A of I source, K destination, highest intermediate vertex K minus 1 plus A K minus 1 Kj. Optimal substructure. Optimal substructure. आप इसको एक्सपैंड करो ट्री फॉर्म में, यू विल सी ओवरलैपिंग सब प्रॉब्लम्स. यू विल सी ओवरलैपिंग सब प्रॉब्लम्स. ठीक है? Shortest path going through. Now this is not going through K, this is going through K. So whichever gives you minimum, that you assign it as K. आनंद 21 डायनामिक प्रोग्रामिंग के लिए ये पॉइंट है, ये कॉन्सेप्ट है कि फर्स्ट योर फाउंडेशन शुड बी वेरी स्ट्रांग. यू शुड डेवलप द स्किल ऑफ डिराइविंग दिस इक्वेशंस. पहले ये आपको आना चाहिए, सो दैट फॉर ए गिवन प्रॉब्लम यू शुड बी इमीडिएटली एबल टू ड्रॉ और डिराइव ए रिकरेंस लाइक दिस. इसके बाद आपने प्रोग्रामिंग में कन्वर्ट करना है. इफ यू फॉलो दिस रोड मैप, इफ यू फॉलो दिस चेक पॉइंट, आई मीन लर्निंग पाथ, देन यू बिकम प्रोफिशिएंट इन डायनामिक प्रोग्रामिंग. ठीक है? So boys and girls, this is a point. Not going through K, going through K. Whichever is minimum, you assign. And this is a decreasing recurrence. So boundary condition क्या बनेगा? A power 0 of ij. A power 0 मतलब there is no intermediate vertex. 0 मतलब कोई intermediate vertex नहीं है. If there is no intermediate vertex between I and J, मतलब I and J should be directly connected by means of an edge. If there is no intermediate vertex between I and J, तो मतलब I and J should be directly connected by means of an edge. And edge cost is given by what? Cij. तो ये हो गया हमारा रिकरेंस. These are recurrence. So my dear students, boys and girls, for every problem repeatedly I am saying you need to develop the skill of deriving the recurrences which follow optimal substructure property with exhibition of overlapping subproblems. Very good. Okay. और एक प्रॉब्लम लेंगे. This is the algorithm which was asked in one of the paper. आप डायरेक्ट फिलअप कर सकते हो. ये बाउंड्री कंडीशन है, Aij you are initializing at cost of ij, and they say intermediate vertex, source, destination, minimum of the equation which we derived, A of ij current value, or going through K, it will be A of ik plus A of kj. और यहीं से आपको टाइम कॉम्प्लेक्सिटी बनेगी फ्लॉयड-वार्शल्स एल्गोरिथम की. व्हाट इज द कॉम्प्लेक्सिटी? दिस लूप इज रिपीटिंग फॉर n स्क्वायर, दिस लूप इज रिपीटिंग फॉर n क्यूब, सो ओवरऑल कॉम्प्लेक्सिटी बनेगी ऑर्डर ऑफ n क्यूब. Floyd-Warshall's algorithm has time complexity of order of n cube. All pair shortest path. Otherwise, अगर आप dynamic programming principle apply नहीं करोगे, तो time complexity would become super exponential, because you will have to enumerate all the paths, all possible paths of length 1, length 2, length 3, length n minus 1. So that become exponential, and therefore this has been reduced from exponential to order of n cube. That is the beauty of डायनेमिक प्रोग्रामिंग. एक और प्रॉब्लम मैं लूंगा जिसका डायनेमिक प्रोग्रामिंग रिकरेंस डिराइव करना आपको बताऊंगा, वो है 0-1 knapsack. वेरी इंटरेस्टिंग. देयर वर क्वेश्चंस इन अर्लियर पेपर्स ऑन दिस. व्हाट इज द डायनेमिक प्रोग्रामिंग रिकरेंस फॉर 0-1 knapsack? 4 ऑप्शंस कैन बी गिवन, 4 फॉर्मूलेस, और आपने करेक्ट फॉर्मूला सेलेक्ट करना होगा. कैसे डिराइव करेंगे? सो बॉयज एंड गर्ल्स, प्लीज लर्न. आई रियली अप्रिशिएट एंड बेसिकली like this derivations. I always love to derive recurrences of new problems of dynamic programming. So अगर आपको भी फ्लेयर है तो आप भी इसे प्रैक्टिस करने पर a proficiency will come and you would start developing that skill of deriving the formulas representing the recurrences for solving the problems. And later coding, वो recurrences को convert करना होगा in the form of code. Best is using C++ और Java. ठीक है? तो कर सकते. कोडिंग पार्ट यू पोस्टपोन इट, बिकॉज गेट में आपको कोडिंग नहीं पूछा जाएगा. पोस्टपोन इट. जस्ट लर्न फॉर गेट व्हाट इज अंडरलाइंग प्रिंसिपल, हाउ डू यू डिराइव द रिकरेंस, देन हाउ डू यू सॉल्व द प्रॉब्लम. इतना आप लर्न कर लीजिएगा, गेट के पर्सपेक्टिव से काफी है. तो चलिए 0-1 knapsack का डेरिवेशन मैं करूंगा. इट्स वेरी सिंपल एंड यू कैन अंडरस्टैंड, यू कैन फॉलो इट. सो प्लीज सी हियर. सो आई ऑलरेडी सेड वी आर गिवन a knapsack of capacity m we are given n objects, and we already said each object has weight wi, each object has profit pi, and for each object हमने कहा we have to make a decision on xi. We've said that already. We want to maximize the profit which is given by sigma pi xi, subject to the condition that the total weight sigma wi xi should be less than or equal to n, where we said the value of xi is equal to 0 or 1. Value of xi is equal to 0 or 1. ये है definition of 0-1 knapsack. So boys and girls, making sequence of decisions. So I have to make decisions on n objects, x1, x2, so on up to xn. ये n decisions मुझे बनाने हैं, ये n decisions I have to make, x1 to xn. That means what is the decision on the first object, second object, third object, fourth object, last object. So I can follow, I can derive a recurrence representing the solution to this in the same way as I have done for previous problems. कैसे करेंगे? How are we going to make the decision? So for that I will assume some variable, some function, like I have done for traveling salesperson, Floyd-Warshall's algorithm. Like that I can make an assumption of some equation. So here we'll say look at this, 0-1 k nap of n comma m. A function 0-1 k nap n comma m, let us say it represent the profit obtainable with n objects and knapsack of capacity. Boys and girls, very interesting. 0-1 k nap of n comma m represent the profit obtainable with n objects and a knapsack of capacity m. ये जो function है represent कर रहा है profit जो आपको मिलेगी with n objects and knapsack capacity m. So how do you derive this? You want to maximize, right? So for that I have to make decisions on this. Look at this. And decision making आप first object से कर सकते हो और last object से कर सकते हो. Making decision from last object will help me make a general formula, last object से. So क्या होगा? Please observe. 0-1 k nap. First question, first point. 0-1 k nap of n comma m is equal to what? What will it be? आपने देखना होगा weight of last object क्या है? What is the weight of the last object? ऐसा हो सकता है, boys and girls, answer me. ऐसा हो सकता है कि last object का weight is greater than knapsack capacity m. ऐसा हो सकता है. If the weight of the last object here, the weight of the last object wn, if it is greater than m, then what is this equal to? This is a dash, fill up the dash. Nishu Kumar, Samrat, Amit Paswan, tell me. If the weight of the last object is greater than m, if it is greater than the knapsack capacity, then the value of 0-1 k nap of n comma m is equal to dash. 1 mark question. This is 1 mark question. अगर last object आप knapsack में place नहीं कर पा रहे हो, if you are not able to place it, then I will have to consider the profit obtainable with how many objects? Nth object आप place नहीं कर पा रहे हो, तो then I have to consider from the remaining how many objects? n-1 objects. Very good. So therefore this will be equal to recursively 0-1 k nap of remaining n-1 objects with full capacity knapsack. This is the case when wn is greater than m. Yes, that's correct. ये है answer. Otherwise, here I am writing otherwise. Suppose, for example, if the value of the weight of the object is less than or equal to m, if the value of the weight of the object is less than or equal to m, then this means that this object can go into the knapsack and I will get maximum profit out of two possibilities. दो possibilities हो सकते हैं. शायद ऐसा हो सकता है कि I may get more profit by including this or by not including this. Just like in all pair shortest path, I may get shortest path by going through K or not going through K, by going through K or not going through K, either of them. So यहाँ पर भी हमें वही करना होगा. Two possibilities. So therefore I apply max of two possibilities, boys and girls. What are the two possibilities? I will remove this for a while. Two possibilities. The possibility is last object I don't want to place. मैं डिसाइड कर रहा हूं, I will not place the last object. अगर मैं last object to place ना करूंगा, ये डिसाइड किया, So then what is the profit that I'm going to get? I will have to consider the profit from the remaining n minus 1 objects. So it will be like earlier occasion. It will be like earlier occasion 0 1 k nap of n minus 1 comma m. Is it not? Whatever profit I get by not including the last object, this is the profit I am going to get. And if I decide to include the last object, xn is equal to 1, अगर मैं decide करूं कि ठीक है I will include the last object, तो मुझे कितना profit मिलेगा? कितना profit मिलेगा? I will get profit of the last object Pn. I will get the profit of the last object definitely, plus profit obtainable with the remaining n minus 1 objects. Last object का तो हमने place किया, तो therefore I will get profit of Pn plus profit obtainable with the remaining n minus 1 objects. तो profit obtainable with remaining n minus 1 objects क्या होगा? Optimal substructure 0 1 k nap. ठीक है, नीचे लिखूंगा profit of the last object plus 0 1 k nap of remaining n minus 1 objects. And now I have decided to include the last object. So therefore the remaining capacity in knapsack is m minus wn. अब जो remaining capacity रहेगी, this is a case when wn is less than or equal to m. जो remaining capacity रहेगी knapsack के लिए m minus wn, because we have placed wn. It's not complex, Dashrath. If you are good in maths, if you are good in recursion, if you are good in data structure, this is very simple. If you are good in maths, recursion and data structure, this is very simple. अगर रिकर्शन में आपको दुश्वारी है तो फिर यह मुश्किल होगी. Very logical. So again I repeat, if the last object is greater than knapsack capacity, then I have to consider the profit from the remaining n minus 1 objects. If the last object weight is less than or equal to knapsack capacity, I have two possibilities. Either I can place the object or I can not place the object. That means x is equal to 0 or x equal to 1. If I say x equal to 0, last object not placed, so 0 profit. So whatever is the profit from the remaining n minus 1 objects. If I decide to include the last object, then the profit of last object. So this is the case when xn is equal to 1. I have written here xn equal to 1. So profit of last object plus profit of the remaining n minus 1 objects. ये है optimal substructure. अगर इसका boundary condition देखो आप, boundary condition, what will it be? Suppose if I have n equal to 0 objects or knapsack capacity is 0. अगर 0 objects हो, knapsack capacity 0 हो, profit आपको 0 होगा. ये boundary condition. This is the boundary condition. ठीक है? So this is 0 1 knapsack. Questions were based on this problem also in earlier occasion. और knapsack के similar और एक question है sum of subsets. Similar to that, 100% similar, another problem called sum of subsets. I would appreciate you try to see the recurrence of this also from any source. कोई भी source से आप sum of subsets का भी recurrence देख सकते हो, dynamic programming का वो भी question आ सकता है. इसके अलावा what are the other problems which you should see as far as dynamic programming is concerned from the examination perspective. मैं यहाँ पर enumerate कर रहा हूँ जो problems आप further जो देखना है, क्योंकि list काफी लंबी है problems की. You can have lot of problems being solved from dynamic programming. जो predominantly important problem जो मैं चाहूंगा आपने देखना है वो है problems like longest common subsequence. String related problem है. Longest common subsequence, commonly called LCS. उसी तरह matrix chain multiplication. Matrix chain multiplication. उसी तरह प्रॉब्लम है बेलमैन फोर्ड, शॉर्टेस्ट पाथ के लिए बेलमैन फोर्ड. फिर एक मोस्ट इंपॉर्टेंट प्रॉब्लम है ऑप्टिमल बाइनरी सर्च ट्री. यहां पर कंप्यूटिंग द कॉस्ट ऑफ बाइनरी सर्च ट्री इज वेरी इंपॉर्टेंट. Computing cost of binary search tree. So I would basically recommend that so far questions were not asked on this, on optimal binary search tree. तो मैं चाहूंगा काफी अच्छा है, न्यू वर्जन ऑफ कॉर्मन में ये प्रॉब्लम डिस्कस किया गया है. तो आई वुड अप्रिशिएट यू प्लीज गो थ्रू दिस ऑप्टिमल बाइनरी सर्च ट्री. काफी इंपॉर्टेंट है, पर्टिकुलरली हाउ टू कंप्यूट द कॉस्ट. इन माय लेक्चर्स regular lectures, regular classes, I have discussed this problem, optimal binary search tree, how to compute the cost. So these are some of the other important problems which I would recommend apart from the problem that I discussed. ये और कुछ problems है जो आप review कीजिएगा as far as dynamic programming is concerned from examination perspective, और इसी के related problems, numericals, questions solve करने की कोशिश कीजिएगा. So that should be more than sufficient enough. हाँ, exactly correct. Rajan, correct. That's correct. Number of successful searches plus unsuccessful searches. Cost is determined based on that. So boys and girls, here I am leaving some more topics for you to compute LCS and so on. Here we will take up some. ये देखिएगा मैट्रिक्स चेन मल्टीप्लिकेशन का भी अगर आपको इक्वेशन पता हो, then you can solve problems like this. इस तरीके के क्वेश्चन पूछे गए हैं मैट्रिक्स चेन मल्टीप्लिकेशन. So if you know the procedure, you can solve this as a matter of homework practice. ये देखिएगा क्वेश्चन. Sometime I'm just trying to show how the typical questions are asked. इस तरीके के भी sometime question have been asked, so you get yourself familiarized. बोलिएगा इसका आंसर क्या है? इसका आंसर बताइए प्लीज. I just am trying to highlight that sometimes the questions are asked in this fashion also. Yes, very clear. Floyd-Warshall's algorithm जो अभी हमने डिस्कस किया for all पे shortest path is based on dynamic programming paradigm. बिल्कुल सही है. इसका ये भी आप क्वेश्चन वर्कआउट कर सकते हो. LCS का डायरेक्ट क्वेश्चन है. If you know the principle of LCS, then you can directly work out this question. That's not difficult. इसका भी देखिएगा आप. Sometimes they ask the question like this. This is basically for longest increasing subsequence. Longest increasing subsequence. मतलब एक set of array elements है in the array. एलिमेंट्स है अरे में, और उसमें लॉन्गेस्ट इंक्रीजिंग सीक्वेंस आपने डिटरमिन करना है. लॉन्गेस्ट इंक्रीजिंग सीक्वेंस, लाइक फॉर एग्जांपल अगर मैं एरे के एलिमेंट दूं 0, -1, -1, 8, 3, 5, 6, 9, फिर 2, लाइक दिस. दिस इज माय एरे. अब ये देखिएगा लॉन्गेस्ट इंक्रीजिंग सीक्वेंस क्या है यहां पर. अब ये देखिएगा 0, -1, 8, यहां तक 0, -1, 8 ये इंक्रीजिंग सीक्वेंस है. यहां पे डिक्रीज हो गई. -1 से अगर आप लो -1, 8, 3 ये नहीं है. -1, 8 हो गया. 8, 3 ये तो बिल्कुल नहीं होगा. 3, 5, 6, 9 लॉन्गेस्ट इंक्रीजिंग सबसीक्वेंस. ठीक है, लॉन्गेस्ट इंक्रीजिंग सबसीक्वेंस. तो उसका जेनेरिक फॉर्मूला है डायनेमिक प्रोग्रामिंग बेस्ड. तो क्वेश्चन ये पूछा गया है कि ये दिस इज बेस्ड ऑन विच स्ट्रैटेजी. दिस अप्रोच ऑफ सॉल्विंग द प्रॉब्लम ऑफ लॉन्गेस्ट कॉमन इंक्रीजिंग सबसीक्वेंस इज बेस्ड ऑन which strategy? Question ऐसा दिया गया है. This is basically worked based on what? Answer is A. Is it not? Based on dynamic program. A dynamic programming paradigm. So sometimes questions like this can be asked. So questions of the form like this, where they ask the formula, they ask numerical computation, or they ask the paradigm and the strategy, or they ask the algorithm. These are the type of questions जो dynamic programming में पूछे जा चुके हैं. ठीक है. अब एक और टॉपिक है जो algorithms की है. I mean that's an overlapping topic with 3 subjects मैं कहूंगा. एक है algorithms, दूसरा है data structures, तीसरा है graph theory. ये टॉपिक जो है graph techniques, it comes in 3 different subjects: algorithms, data structures, and to certain extent graph theory. Graph techniques or graph traversals. Point number 1, I will make a brief review क्योंकि आपने हो सकता है डेटा स्ट्रक्चर्स में भी पढ़ा हो. तो ब्रीफ रिव्यू, इंपॉर्टेंट पर्सपेक्टिव मैं थोड़े डिस्कस करूंगा. कुछ प्रॉब्लम भी हम प्रैक्टिस के सॉल्व करेंगे सो दैट यू कैन हैव सम रिवीजन. सो सुनिएगा. I don't want to go into much depth like earlier occasion of divide and conquer and greedy method and dynamic. Basic overview, क्योंकि दिस इज ना वेरी सिंपल टॉपिक फॉर यू. लेकिन इसमें कुछ इंपॉर्टेंट पर्सपेक्टिव्स है जो मैं चाहूंगा इंपॉर्टेंट है, मैं हाईलाइट करूंगा. सुनिएगा. ट्रैवर्सल, विजिटिंग द नोड्स इन अ पर्टिकुलर ऑर्डर एंड प्रोसेसिंग द इंफॉर्मेशन वंस इज कॉल्ड ट्रैवर्सल. फंडामेंटल डिफरेंस बिटवीन ट्री ट्रैवर्सल एंड ग्राफ ट्रैवर्सल क्या है? फंडामेंटल डिफरेंस बिटवीन ट्री एंड ग्राफ ट्रैवर्सल क्या है? एनीबडी? निशु कुमार, सम्राट, आनंद, what is the fundamental difference between tree traversal and graph traversal. Generally people have a confusion here, तो मैं वो उससे पहले resolve करना चाहूंगा. According to you, what is the fundamental difference between tree and graph traversal? Anyone? Can anybody tell what is the fundamental difference between tree and graph traversal? No, यश बेदी, आप ये नहीं कहोगे कि ट्री ट्रैवर्सल बिगिन फ्रॉम रूट एंड ग्राफ ट्रैवर्सल फ्रॉम लीफ, ऐसा है क्या? नहीं. Sayan Datta is saying tree traversal start from root, graph can start from any vertex. तो जिसकी वजह से एक इंपॉर्टेंट प्रॉपर्टी होगी, सुनिएगा सुनिएगा सुनिएगा. Tree traversal like pre-order, post-order, in-order of a binary tree, for example, is always unique. Nishu Kumar. Tree traversal is always unique. Graph traversal is not unique. Meaning, for a given tree, I can have only one pre-order, one post-order, one in-order. Particularly on binary trees. For a graph traversal, I can have multiple graph traversals, multiple depth first search, multiple breadth first search. सही है? Because you can basically start from any node, as we are saying, and you can visit in any order. So I can have multiple depth first search, multiple breadth first search for a given graph. ये fundamental difference है between tree and graph traversal. Traversal is a very important operation on most of the on the graphs, and very unique applications of it in operating systems also. जैसा file system का traversal जो होगा, it is based on graph traversal. There are many highlighting applications of it. So I have depth first search and breadth first search. Okay. लेकिन depth first search के लिए मैं ये चाहूंगा you get yourself familiarized with some important topics, important concept in depth first search, like discovery time. Discovery time. What is the concept of discovery time, and what is the concept of finishing time? Because there were questions based on this aspect. D value and F value, D value and F value of a particular node X. Every node during traversal, particularly for depth first search, will have discovery and finishing time. Discovery time is the time at which you discover the node, visit the node for the first time, and finishing time is the time at which the node becomes dead. जब node finish हो जाएगा, dead हो जाएगा, then you have finishing time, discovery and finishing time. And next, I just wanted to basically remember what data structures are used in the implementation of depth first search and breadth first search. As Nishu Kumar has rightly pointed out, depth first search uses stack and breadth first search uses queue. Depth first search uses stack and breadth first search uses queue. Queue generally following FIFO discipline, first in first out discipline, so first in first out queue. So I don't want to, because I'm very sure that basically डेप्थ फर्स्ट सर्च आपको पता है कैसे करते हैं, ब्रेडथ फर्स्ट सर्च अभी आपको पता है कैसे करते हैं, लेकिन सिर्फ एक छोटा सा एग्जांपल मैं यहाँ पे ये देकर देना चाहूंगा. आई विल ड्रॉ ए ग्राफ, उसके कुछ डेप्थ फर्स्ट सर्च में एन्यूमरेट करूंगा. आपने सेलेक्ट करना है कि विच ऑफ देम आर वैलिड एंड विच ऑफ देम आर इनवैलिड, विच ऑफ देम आर इनवैलिड फॉर ए पर्टिकुलर ग्राफ. सी हियर ऑन बोर्ड. I will name these vertices A, B, C, D, E, F, G, and H. So here I'm asking you to mark valid or invalid DFS traversal orders. Assuming that you know the philosophy of depth first search and breadth first search, I advise you to mark as invalid or invalid. So I'm marking like A, B, D, F, E, F, C, G, B. I will start like A, C, F, H, E, D, B, G. ठीक है? And then I have H, G, C, F, E, A, B and D. Then I say D, B, E, H, D, B, E, H, F, C, G, A. I have marked 4 traversal orders. You have to tell which of them are valid and which of them are invalid depth first search traversal. Come on, boys and girls. Which of them are valid and which of them are invalid depth first search traversal orders? First one is valid. अगर invalid हो तो you have to tell me why is it invalid. Which one are invalid? Which one is invalid? Why is it invalid? You have to say why is it invalid. B, let us say A, C is possible, F is possible, H is possible, H के बाद E also possible, E के बाद D आप process नहीं कर सकते. Here I have invalidity. Correct? Invalid. Next, H, G, C, HGC possible, HGC. F is possible. After that, E is not possible, boys and girls. F के बाद E नहीं हो सकता. C is invalid. D is valid. क्या D valid है? निशु, श्रीजा, आनंद, tell me. हाँ, पार्ट 2 भी आएगा. डोंट वरी. पार्ट 2 PYQ भी आएगा. नो वरीज. पहले महा रिवीजन कंप्लीट कर रहे हैं, उसके बाद PYQ पार्ट 2 भी करेंगे. F के बाद देखिएगा H, G, C, F इज ओके. F के बाद E नहीं आ सकता. F के बाद आपने A प्रोसेस करना है. C ऑप्शन C में. D is valid. Okay, D, you're starting from D, then B is possible, then E is possible, then H is possible, then F is possible, then C is possible, then G is possible, A is possible. A and D are possible. A and D are possible. Boys and girls, डेप्थ फर्स्ट सर्च में मैं ये चाहूंगा कि जो बहुत ज्यादा इंपॉर्टेंट है वो डायरेक्टेड ग्राफ्स. डेप्थ फर्स्ट सर्च इन डायरेक्टेड ग्राफ इज सुपर इंपॉर्टेंट. वहां पर डेप्थ फर्स्ट सर्च व्हेन परफॉर्म्ड ऑन डायरेक्टेड ग्राफ्स, लुक एट दिस. Depth first search when performed on directed graphs will lead to the following types of classification of edges. क्या है? 4 types of edges: tree edges, back edges, cross edges, forward edge. श्रीजीत, क्या प्रॉब्लम हुआ? क्या प्रॉब्लम हुआ यहां पर? बैकट्रैकिंग है ये. D देखिएगा, D, then B, then E, then H, possible D, B, E, H. इसके बाद मूव करना है आगे. F possible. C के बाद या A जा सकते हो या G जा सकते हो. वी हैव गॉन फॉर G. तो फिर यहां से बैक ट्रैक करोगे, बैक ट्रैक करके A पे आओगे, A प्रोसेस किए. दैट्स इट. वेरी सिंपल. बहुत सिंपल है ये. दिस इज वेरी सिंपल. So boys and girls, when you perform depth first search on directed graph, I am to tell you that the depth first search spanning tree forest जो generate होगा. Yes, Samrat, that's possible. You can visit backtracking as long as it is there. So boys and girls, when you perform depth first search on directed graphs, it will lead to production of something called forward. यहाँ पे लिखा हुआ है देखिए, right? Tree edges are part of spanning tree. These are tree edges. Maybe I have directions like this. Maybe I have directions like this. These are tree edges. Then I can have a forward edge. What is a forward edge? A is not possible, Srijit. I will come back. Let me complete this. Forward edge will lead from a node to its non-child descendant. ये descendant है, grandchild. An edge connecting from a node to its non-child descendant is called forward. Back edge क्या होगा? It will connect from a node to its ancestor. ये node ancestor है ये node की. So if I have an edge from here to here, that is called back edge. And an edge connecting from a node to another node which is neither ancestor or descendant, then that is called cross edge. देखिएगा, these two are siblings. So if I have an edge like this is called cross. So forward lead from a node to its grandchild. Cross or back, it will go from a child to its ancestor, from a node to its ancestor. And cross will go from one node to another node, which is neither ancestor nor descendant. तो बॉयज एंड गर्ल्स, इसके प्रॉपर्टीज फॉरवर्ड, बैक एंड क्रॉस एक पैरेंथेसाइजेशन थ्योरम है, वो थ्योरम से आप कैरेक्टराइज कर सकते हो डिस्कवरी एंड फिनिशिंग टाइम के बेसिस पर ये क्लासिफिकेशन ऑफ एडजेस. एंड देयर आर नंबर ऑफ प्रॉपर्टीज बेस्ड ऑन दिस व्हिच यू स्टडी इन डेटा स्ट्रक्चर्स एंड आल्सो हियर इन एल्गोरिथम्स या फिर डिस्क्रीट ग्राफ थियरी में ट्री, बैक, क्रॉस, एडजेस के प्रॉपर्टीज. ठीक है, इसका एक वेरिएशन है डेप्थ फर्स्ट सर्च यू कैन कैरी आउट ऑन directed acyclic graphs. When you carry out depth first search on directed acyclic graphs, it will lead to production of what is called topological sort. You know, topological sort is a linear order. काफी क्वेश्चन पूछे जा चुके हैं इसके ऊपर भी. Linear order of visiting the vertices, obeying the precedence graph. Directed acyclic graph पे होगा. Like for example, ये देखिएगा डायरेक्टेड असाइक्लिक ग्राफ है DAG, and this is one of the topological sort. You're starting from a node which is source node and it will end with sync node. Sync node क्या है? Which will not have any outbound edges. Source node क्या है? Which will not have any incoming edges. So many questions in earlier papers based on topological sort. This is also a pure application of depth first search. Linear order of basically, देखिएगा इसके topological sorts क्या है? I can begin from B. Look at this. I can go to A or I can go to D. There are two options. If I come to A and basically after A to process C, I should complete A and D. So after A, I will have to D, I will have to visit A. इसके बाद I can go to C. Here I can go to C. After C, I have two options. Either I can go to E or F. So I can go to E or I can go to F. I can go to E or I can go to F. After E, I should finish F. After F, I should finish E. After E, finish F. After F, finish E. So this graph has got 4 topological orders. 1, 2, 3, 4. Topological order is also quite important. Linear order, maintaining the precedences or obeying the precedences. इसका भी algorithm is based on depth first search. ठीक है? This is another example you can try from the textbook of Corman. ये tough, one of the complex graphs है, DAG है ये भी. This is also DAG. You can think of topological orderings. And then you have breadth first search, level by level traversal of the graph. Breadth first search. Breadth first search की एक important property characteristic ये है, it will lead to producing shortest paths from a single source with best possible time, optimal time, provided the graph is unweighted graph. Breadth first search. Breadth first search uses Q as a data structure or level by level processing होगी. So for this graph, for example, if you perform using breadth first search, then how? I start from A. Then you can visit either B or C. Maybe I visit B then C. Then I can visit in the same order D, E, F, G. Of course, this is a tree and you can perform even for tree or a graph. Breadth first search. Okay. देखिएगा level by level traversals. Level 0, then level 1, then level 2, like that it processes. And then we have some more important properties of or applications of depth first search. Properties or applications of depth first search, like for example, components. Connected components, strongly connected components, bi-connected components. These again an overlapping topic आपने discrete mathematics में ही पढ़ा होगा. So these are also applications of depth first search and breadth first search. How to compute connected components, strongly connected components, bi-connected components, articulation points, bridges, cut vertices. These are all the applications of depth first search. Like for example, there were questions asked in earlier papers based on strong connected components. Just as a matter of fact, मैं आपको पूछ रहा हूँ, देखेंगे कितने बच्चे correct बताते हैं. Can you, if you know what is strongly connected component, it is a partition with the property that all the vertices which are there in the component are strongly connected for a directed graph. Strongly connected components are basically for directed graphs, and the most popular algorithm for determining the strongly connected components based on depth first search is a famous algorithm called Kosa-Raju. कोसराजू एल्गोरिथम है, टार्जन एल्गोरिथम है फॉर डिटर्मिनिंग स्ट्रांगली कनेक्टेड कंपोनेंट्स. So boys and girls, can anybody tell me this graph given here, 2-mark question, this graph given here has got how many strongly connected components? Can you tell me? This given graph has got how many strongly connected components? Come on. अमित पासवान नो. देखेंगे कितने बच्चे बताएंगे. I hope you are able to see the directions on the edges. You are able to see the direction of the edges. BE is strongly connected, yes. इसी तरह CF is strongly connected. But these two are independent, so single vertex is strongly connected. Single vertex is always strongly connected. And this whole segment, if you see, is strongly connected. Because for any two vertices you take, they have a path. They have a path, directed path. They have a directed path. Any two vertices you take, they have a directed path. So boys and girls, this graph has got strongly connected component 1, strongly connected component 2, strongly connected component 3, strongly connected component 4, strongly connected component 5. So this graph has got 5 strongly connected components. Strongly connected components के भी कुछ properties है, like every directed graph is a directed acyclic graph of its strongly connected components, one of the property. ठीक है? Like that you have basically articulation vertex, cut vertex. Articulation vertex or cut vertex is that vertex, the removal of which will cut the graph into 2 or more non-empty components. Like ये graph में बताइए कितने articulation vertex है? This graph has got how many articulation vertex? Come on, boys and girls. This graph has got how many articulation vertices? Cut vertices. It is a vertex which is going to cut the graph into 2 or more non-empty components. That is also an application of depth first search. Yes, this blue vertex is articulating. अगर ये vertex को आप disrupt कर दो, remove कर दो, I'll get one component here, another component here. 2 or more non-empty components. Like that, you tell me for this graph how many cut vertices, boys and girls? How many articulation points are there in this graph? Come on. Yes, 3 is articulating, 2 is articulating, 5 is articulating. So this graph has got 3 articulation points. That's correct. 2-mark question. Like that, you can try for this here. This graph has got how many articulation vertices? It has got 2, 3, and 4. These are articulation vertices. So some questions like this. These are all the questions from the PYQs. Articulation vertices. ठीक है? Yes. Some practice question to test your knowledge. Maybe something you may be knowing or you may not be knowing. यहाँ पे मैं आपको बता दूंगा. अगर if you perform in a depth first search of a graph with n vertices, k edges are marked as tree edges, then the number of connected components of graph is dash. What is the answer? Is standard question. ये standard formula है, आपने remember करना है. Of course derivation भी है, बहुत simple है. Derivation भी है, बहुत simple है. What is answer? Anybody? Yes. The number of connected components for a depth first search of an undirected graph. The number of connected components of depth first search of an undirected graph is always n minus k. You can prove it by taking a sample example. एक example ले सकते हो आप. For instance, I have a graph like this. Undirected disjoint graph like this. Like this. This is my undirected graph. ये मेरी अनडायरेक्टेड डिसजॉइंट ग्राफ है, अनडायरेक्टेड डिसजॉइंट ग्राफ है. When you perform a depth first search of this, you will find that the number of connected components will be 2 and you will get the answer with n minus k. ठीक है, इसका आंसर बताइए, देखेंगे कितने बच्चे सही बताते हैं. दिस इज फ्रॉम गेट डीए पेपर. Consider the following undirected graph on 5 nodes. Performing breadth first search on this graph using a Q data structure. Yes, Nishu Kumar, that's correct. How many unique breadth first search orderings are possible in this graph? How many unique breadth first search orderings are possible on this graph? Come on, boys and girls. (120). See here. If I number the nodes as A, B, C, D, E. So if I start from E, अगर हम E से start करेंगे तो कितने possibilities है? 4 factorial plus. If I start from E, I have 4 factorial plus. अगर हम A से start करें, then I have from A I have to go to compulsory E. Then I have 3 possibilities, 3 factorial orderings with 4 from one vertex. Like that, I will have 3 factorial for the remaining 3. So therefore, 3 factorial into 4 vertices. 1, 2, 3, 4. So these again 4 factorial. So it is 4 factorial plus 4 factorial. 4 factorial is how much? 4 into 3 into 2. 24 plus 24, 48. So therefore, the answer is C. 48. Very simple. चलिए next. टोपोलॉजिकल ऑर्डरिंग, एक लास्ट क्वेश्चन बताइए. टोपोलॉजिकल ऑर्डरिंग, विच ऑफ द फॉलोइंग इज और आर, क्वेश्चन इज और आर पूछ रहा है. वैलिड टोपोलॉजिकल ऑर्डरिंग ऑफ दिस ग्राफ. ये भी PYQ है. दिस इज ऑल्सो ए PYQ. Yes, this is a question asked in GATE DA paper. GATE DA. So I can start from either P or R. So PQ is not possible. PQ is not possible. PR is possible, yes. Then after PR I can go to Q. After Q I can go to either V or S in any order, and then U and T. This is possible. PQ is not possible, I already told. PRQ, this is also possible. PRQ, then SV in any order, and then T and U. So therefore B and D are correct. B and D are correct. Give me the answer for this. ये फॉर्मूला हमने डिराइव किया, हमने फर्स्ट क्वेश्चन में डिराइव किया था, उसके ऊपर न्यूमेरिकल क्वेश्चन. हाउ द क्वेश्चंस आर आस्क्ड रिपीटेडली. लुक एट दिस. How the questions are asked repeatedly. कितने number of connected components होंगे? Very direct. Just now we said the number of connected components are n minus k. N is equal to 100 and number of edges are 40. So therefore the answer is straight away 60. Straight away 60. That's it. Okay. So these are the topics which I thought I should discuss. So at the end I would just like to make a mention of the list of important topics from my side. From analysis part, I expect that you are well versed with asymptotic notations and its relevant problems. जहां पर आपने you should have the expertise for deciding the rate of growth of the functions, increasing, decreasing order, determining which function is in the order of the other, properties of asymptotic notations, right? For that mathematical background काफी important है. So based on that, make an assumption that definitely two or three questions will come from asymptotic notations. इसी के ताल्लुक से then basically I would appreciate you also get well familiarized with the analysis of recursive algorithms. Analysis of recursive algorithms. Another important aspect is loop complexities. These are essential topics and important topics that you can consider from unit 1. Then in divide and conquer, what I expect is you be well versed with merge sort. Generally questions are asked from here, quick sort, and familiarize with master method, because master method is for divide and conquer recurrences, and likewise for recursion tree method. Okay? Of course, there are other problems like Strasson's matrix multiplication है, long integer multiplication है, and thing. Sufia Ahmed, same thing रहेगा DA में भी, same thing. जो topics मैं यहाँ list कर रहा हूँ वही रहेगा, except for greedy and dynamic programming for DA. Then from greedy method, the important topics I would say Knapsack, Huffman coding, then spanning trees, super important, and Dijkstra's algorithm. These are important ones. Dynamic programming, understanding optimal substructure, elements of dynamic programming, elements of DP. You should have understanding of this. Approaches like top down and bottom up, and then all pairs shortest paths, Floyd-Warshalls, longest common subsequence, matrix chain multiplication, okay, and 0-1 knapsack, sum of subsets, and optimal binary search. These are important list of problems in dynamic programming. Yes, Nishu Kumar. Overlapping subproblems and optimal substructure. ठीक है. Next, I have graph traversals. Depth first search, both for undirected and directed graphs. Both for undirected and directed graphs. Breadth first search. Lastly, applications. Applications में particularly strongly connected components. Strongly connected components, topological order. These are important ones. And finally, I would also say, as a matter of fact, generic topic जो मैं data structures में भी आपने पढ़ा होगा, programming में भी आपने पढ़ा होगा, वो है sorting techniques, general discussion. Make yourself well versed with properties, characteristic of sorting techniques like comparison, non-comparison based sorts, selections, stable versus unstable sort, in place and not in place sort, these properties, characteristics. Plus, Srijit, for GATE, DA, greedy and dynamic programming are not important. For DA, it's not important. For DA, graph traversals, divide and conquer, asymptotic notations, analysis part, that is important. And for GATE, DA, again, sorting and searching also for GATE, DA. So sorting may basically, I expect that apart from quick sort and merge sort, you also make yourself familiarized with heap sort. And basically like insertion sort, selection sort. And in non-comparison based, you can basically see radix sort. Bubble sort to ek hai technique that is very simple than nothing. So make yourself a study of all this. So if you focus on these topics, I am very sure for GATE DA, you can focus more on sorting and searching also, which is very simple. Yes, heap तो आप data structures में पढ़े होंगे, निशु कुमार. Heap आप पढ़े होंगे data structure में. So boys and girls, this is what I had to discuss with regard to algorithms in short form in Maha Revision point of view. Okay. And finally, I say that you prepare without any much worries. Okay. Because my approach of teaching, I believe in fundamentally a concept. Mera famous saying hai, I always believe in teaching with a philosophy of worst case preparation to face the exam in best case. This is my philosophy. Because I try my level best to teach in the worst case. I try to teach the students to the depth in the worst case with an assumption that you should be knowing the foundations or basic. तो और मैं जब worst case के लिए prepare करता हूं तो some teacher will consider me as worst teacher. Unfortunately, when I try to concentrate on worst case preparation, some students try to basically consider me as worst case because I'm teaching in worst case behavior, so that you are in the best case behavior in the exam. अगर आप worst case prepare नहीं करोगे, if you are not trying to prepare in the worst case, समझ रहे हो, then if you prepare in the best case, आराम से छोटे छोटे प्रॉब्लम सॉल्व कर लो, बहुत आसानी से समझने की कोशिश करो. बेस्ट केस प्रिपरेशन एग्जाम में वर्स्ट केस होगा. ये मार्क करके रख लीजिएगा आप वर्ड. You mark this word. I've been teaching for GATE for the past 99, so I don't need any certificate from anyone how I'm teaching, best या average या worst. ठीक है? I can only say one thing: if you are facing difficulty with this teaching, there is a heavy probability, there is a heavy chance, heavy probability that you may not get your desired rank. You mark my words. You may not get desired marks. Because the reason is simple. I'm not trying to basically compare myself with anyone or compare with others or anything. I don't have to do it. I also consider all my students who are teachers and non-students who are my teachers as wonderful teachers. They're all good. But I'm telling you, अगर ये आपको difficult लग रहा है, this teaching, then you mark my words that it may be difficult to crack with your desired percentile. That is what I would say as a litmus test. As a litmus test. समझ रहे हो आप? हाँ, you may find, some people may find difficulty. I'm not saying. तो वही कहा ना मैं. Those who feel that the teaching level is basically like worst case, worst teacher, no issue. I don't mind. जैसा depth first search है, breadth first search है. I try my level best to cover both breadth and depth. जिसकी वजह से डिफिकल्टी होती है बात बच्चों. नो वरीज, बिकॉज मेरा इनहेरेंट अजम्पशन होता है, I inherently assume that there are certain fundamental things that I assume the student should be having. If you don't have, then you will have problems. Because my intention is not to prepare you for your academics. थोड़ा फाउंडेशन होना जरूरी है गेट के लिए, वरना सिर्फ मेरा अगर इंटेंशन होगा टू क्रिएट एकेडमिक्स, देन व्हाट इज द यूज ऑफ गेट. फंक्शन में डिफिकल्टी हो रही है, log n log n log n, कौन सा बड़ा है कौन सा छोटा है, डिफिकल्टी हो रही है, ये तो समझाते नहीं है सर. अब मैं क्या करूंगा बोलिए आप? डू यू एक्सपेक्ट मी टू एक्सप्लेन बाय सब्स्टिट्यूटिंग द वैल्यूज? दैट्स नॉट पॉसिबल. एनीवे, just now during break time some student has put a comment, so therefore I thought of making some simple clarification for that. Right? So my approach, everybody will have their own approach, please understand. I focus on foundation, I focus on concept building. You ask my students are there since 99, 2000. and some of them are still in touch with me and they are in very good position. So therefore you ask them. My intention is not basics, no. I mean थोड़ा पढ़ा दो, बेस्ट केस में रहो, एग्जाम में जाके वर्स्ट केस, फिर वहां पे अरे भाई क्या पढ़ा क्या आ गया, ऐसा नहीं. Have a struggle now so that you are in comfort level in the exam. That is my intention. So boys and girls, I hope those who have really prepared for GATE, this revision might have been of some use definitely to certain extent, which would be justified, but still, no Aditya Bilkade, nothing like that. There is no concept of God or anything like that or superior. Every teacher is also a learner, he has to consider himself as a learner, always learner. Now also I am learning, definitely. Okay? So with due respect to all of you and due respect to all the teachers, again I re-emphasize that playing gimmicks is not correct in being a teacher. Okay? So I wish you all the best and pray to Almighty that you have a grand success in your career and you become a wonderful person in your life, and you serve not only the nation but the whole humanity with a pure heart, I've been teaching for now more than 32 years, so I never differentiated between any kind of students. I love to all my students basically and expect the same from others. So definitely I am also expecting you all to meet some or the other time. Those who are in Hyderabad, you can come to GFG Center and meet us during the GATE exam analysis. Okay? So that's it from my side for this wonderful session and wonderful participation from your end. I think many of you have interacted and got some benefit out of this session and will continue to serve. So all the best. Definitely Tulika and other people, I also will be very happy to see you some or the other time in the later, coming time, definitely. So thank you so much again and wish you all the best. Good night.